just about everything we need. Great. Hi, everybody, and welcome to the Keshe Plasma Reactor Group. Once again, it's January 24th, 2017. We have a new president of the United States. It's been inaugurated this week, and it's a big event, and already things are shaking up in the world. So we're looking forward to interesting times, as they say. There's a saying, may you live in interesting times, and that means when things are shaken up a little bit, and it's for better or for worse. It'll always be for the better in the end, no matter what happens, because we'll find those that are peaceful will find a way through it all anyway. So let's begin today's little round of things. Let me see. I like to usually refer to Lee Coates. He's got his video up here. And just as a reminder, if people do accidentally start their videos or whatever, I understand that the recording records the full view of videos that are up at any time as well, besides the one that's highlighted. So just keep that in mind. Okay, well, let's switch over to Lee, see what he's got going there. What's up today, Lee? You have a lonely looking little coil
Hi,
there.
everyone.
Usually you've got so much, coils upon coils. Are you highlighting this coil, or is it the box beside it that is or is it the little yellow things there? I don't know. I'm totally, let you take it over here. I could guess all night.
Well, I like it the way Mark always shows his work in progress every week. So
Yeah.
this is a project I started back in December. It was going to be a Christmas present for my mom and dad. So it's a little bit late in the making, but we'll get there eventually. So it's what is a hand scanner or a health device for you. You have a coil in the box below and a coil in the box above, and that's the coil that's going to go in there. It's got the 14481 coil arrangement, standard Magrav coil. And that's a plasma ring with hemoglobin GANs in it. And I got this idea from Tibor from Norway. Hope I pronounce his name right. And I always like his stuff because he makes all his stuff out of wood. And I'm a carpenter, cabinet maker kind of guy, and here I am making all my stuff out of plastic and steel and rough plywood, and so I was going to make something really good. So this is it's not totally assembled yet. It's not finished, of course. So I just show you what I got on the go here. And
is this something that has no nails in it? It looks like it has special tongues in the corners and whatnot. Is that the way it's held together, or?
Yeah, these are miter joints, and this is called a spline miter.
Right.
They're not glued in yet, but
oh yeah.
I just stuck some.
And was that deliberate to not use nails, to not use the metal in the contraption, or is that beside the
no,
issue?
this is a standard cabinet making joint that we use all the time.
Yep.
On the back one comes off. I got just two screws hold it on. The splines will be glued to the one half, and then when they go together, the spline and the miter will sort of intersect and tie it together.
Mm-hmm.
And then these two little cross pieces on the side. That's like two pieces of wood. I was going to cut it like a lightning bolt in there, and just for decoration in the middle, and and round over the edges, make it a feature.
Yeah.
But
nice.
Anyway, and then
so
the power.
Right. I was going to ask you, is it powered? How are you going to work that?
Well, T-Bar had powered it with a plasma battery or battery capacitor. I was thinking maybe I had these little mini car Magravs. I was wondering if I could stick them and put a little box around them, stick them inside and in between, and power them with car Magravs. I've never had much luck making the plasma battery capacitors because when I measure the voltage on them, I never seem to have any voltage. So I'm not never sure whether I'm making them right. So so I thought I know I can get power out of those guys. So I was thinking using that for the power, but haven't got that built in yet.
Oh, nice.
So
well, that's an interesting idea. So I guess it would work for what, your hand and arm you could stick in, and maybe your foot even?
Yeah, like the way Tibor described it, this is a poor man's universal health unit. And what it does is it uses, all the different points on your hand that go to the different points in your body. So you put your hand in the field, and it, I guess, it flows through, gets to all parts of your body through your hand. It's not nowhere near as fast as the universal health unit. You got to hold your hand in there a lot longer, apparently. So I'm giving it a try. See how it works.
Interesting. Okay. I wonder if you could put things in there like a vial of something to charge it, some Gans water or something, or some sort of something you wanted to put in between the fields. Put an apple beside the apparatus and put one inside and see which one lasts the longest, or something like that. Maybe it would rejuvenate things. Maybe it'll make razor blades sharp, and you could become rich and famous, like the ones that were put in the pyramids back in the 70s, I think it was, and it became a what do they call it, an urban legend about razor blades could be sharpened by putting them inside a pyramid structure.
Who knows?
Yeah, who knows?
Could experiment and try see what happens.
Yeah.
Well, technically a razor blade is a little pyramid.
Well, I guess so. It's home to a razor edge, but it is an actual pyramid tip on the edge. Is that what you meant, Peter? Or
yeah.
I just on this box I left the top as acrylic plastic so they could sort of people could look inside and see the coils and
that's nice,
and get an idea what's inside there, just otherwise they'd be curious.
Yeah.
And then the other ones I'm just putting the plywood top and bottom, and on the bottom ones. So.
Right, maybe you could put some felt or something for people to rest their hand on, or some sort of surface there.
Possible.
That's neat.
You could always spike some sort of organic coating, like clear coat, all over the wood, just like it'd be like a lacquer or something like that, but not inorganic. It'd have to be organic. And then have it spiked with Gans, some Gans water or anything like that, like CO2 or something, for an additional effect, I guess.
Yeah, it's possible. What if you did have, for example, a water-based paint, or shellac type stuff, or lacquer, not lacquer, but what do you call it, water-based acrylic of some sort, and put in the Gans right in the acrylic, and you could paint it on. You'd have a Gans coated apparatus, which could be kind of cool.
Now, I was going to put CO2 Gans on the coils on the bottom and CH3 on the coils on top. What do you guys think? Do you think I need a Gans ball in the middle of this too, or? I know Tibor didn't have one.
You will, Lee.
Okay.
It makes sense, yeah, and probably you'd want a gradient between the two to provide a field in between, right? What would you say, John?
What came to my mind the other day, I was thinking about this for the last couple of weeks, and what came to my mind was the center ball being copper oxide with a drop of CO2, the inner loop being CO2 with a drop of CH3, and the outer loop being CH3 with a drop of copper oxide. That way you're linking the three fields together in a direction that you dictate by the interaction of the drops. And you're going from strongest to weakest on the outside, or strongest to lightest on the outside. Don't know if that's
Big.
absolutely accurate, but that was, I was coming down the stairs and I just got this brain flash, and so I'm getting some people to test that. I don't have any GANs right now. It's hard to make in my house, so I'm nano coating some plates. I'm going to try again here shortly.
Okay, that sort of makes sense with the one coil. What about from the bottom box to the top box? I'm thinking there should be a gradient there too.
Something just on kind of a side note on one of the discussions, Mr. Keshe mentioned that you can get that gradient by the volume of the GAN. So you put more on one than on the other.
Okay, so you'd want more on your gravitational and less on your magnetic?
I would probably do the same mix for each one, but you do one set of coils and then dilute your GANs mix to do the second set.
And the flow would go towards the diluted coil, from the strong coil to the diluted coil?
That's the way I understand it, yeah.
What about the GANs ball? Would you use, for example, one ping pong ball on the bottom and one on the top that had a diluted mixture in it? Or would you use a ping pong ball on the bottom and say a baseball-sized ball on the top or something like that?
Probably both would work. I would probably just stick with having one as a paste and one as a fluid. At least to start with, anyway. I mean, we're all just learning on this stuff, and we're not really sure what direction to go. But that does seem reasonable to think of it in that fashion.
Yeah, we talked a bit about gradient before, trying to figure out this idea of the dilution factor and what that means, and would it mean you could have the same concentration, like you take the same GANs water but just two different volumes, one say twice the volume of the other, and that would provide the gradient. Or you could look at it as having, say, the same volume, but one would be 1/10 of the concentration of the other one in terms of more distilled water added to it.
Yeah,
and that would provide a gradient.
Which would essentially be the same thing. You're just using the same size containers in that case, that's all.
Mm-hmm. Interesting thing to think about that way. Okay, anybody else have some questions or comments about that?
Yeah, hi guys, my name is Tom. I'm from London. Good morning.
Hi.
I guess one question to us to the story with the stacker, because I got my own experience with the big medical system, and I use painting. And the idea with this gradient, when I actually made, was quite simple. I was take the liquid gases, just normal liquid gases. I mean, it's not liquid plasma like water, it's just gases from the water. Really small amount, really. And also CO2 and zinc gas, of course, with some special combination, special proportion. And that was the wet gases. So the concept was very basic. Mixed them with the painting, but the silicon painting, because the different bound inside. I mean, the silicon is much more closer what I'm looking for. I mean, basically expand all the field much more better, I think. And after painting, you just need left the stuff for, I know, 24 hours minimum. Mostly there's gonna be 3-4 days, something like that. And on everything, and that was basically happened. Everything when you put to any object, the painting, is wet, and they get different type of fields. So by these 3-4 days, everything go dry. So they completely change the fields. So you got actually two fields inside one object. So that's the sort of idea for the gradients. That's what I'm using very often now. Just like a two gas, that's all. I mean, this is only one gas, but one condition is dry, another condition is a wet. I mean, I'll go start for the wet condition, and after a few days, everything got dried, and I get some like a strange combination. So worked fantastic actually. I was check on my health system I built now. Just like a kind of pretty strange looking system. The columns, the white columns, the black coils inside, 5 columns, 5 coils inside the 1 columns. It's the kind of mobile system. And the most bigger discovery was when I just put the 2 columns across and just stand inside between the 2 columns. There was completely just clean columns. We have no any coils, nothing like that. Just only painting with these ganses, and the feels was quite strong. I mean, it was very easy to feel. Was the stream inside and all this kind of things. So that was my experience.
Plastic column or wooden column?
Cardboard.
Oh, okay.
Very specific reason. Actually, we got amazing tools around. The cardboard is, I think, I mean, it's fantastic material, because the way how they made this substance is interesting. They actually grinded all the old paper from recycling and put to the big dishes with caustic soda. So that's the reason why they take out all this rubbish from the old paper. And actually, we already get kind of gases from the cellulose, because the cellulose, which is paper, is that's the gases, basically, mostly CO2. I mean, not only, it's probably a huge combination. We don't know actually in full scale, but this is the GANs, and everything is already nano-coated, because this is the nanotube. Basically, this is pretty much same construction like every single material with the nanotubing inside.
Yeah, that's a good point. And besides that, it's quite absorbent too. It can absorb the GANs that you put on and so on.
Yeah, I mean, I got camera. If you guys like to look,
sure.
I'll briefly show you.
Yeah, Thomas, if I might jump in here, one error in what you just mentioned, when you're mixing caustic with a material, you're not creating a GANs, you're creating a nano-material.
Yeah. I mean, this is the story how they make. Sorry, that's my camera, crazy camera. This is the story how they make the cardboard, and I just use normal full working cardboard tubes, something like that. This is the already painted. And that's the combination of 2 ganses. And so I wait now for next 2 days. It's gonna be dry completely, and I will start packing and loading with all these coils like here. And this is the final effect, final stations.
What was that cardboard, like a brown color to start with, and now it's white, or was it white to start with?
Oh, I don't want. I will show you, because I don't like it.
I'm wondering.
Small samples.
What kind of, did you use like straight GANs, or was there any paint or some other sort of solvent with it, or carrier?
This is actually, I will show you. This is old tube after, I don't know, some carpets, something like that. If you go to shop with the carpets and all this crazy stuff, they probably got thousands of empty tubes, and they mostly get problem put all these things to the skip. And if you ask about something, they're gonna be very happy probably, because there's less problem from them.
Right.
This is just normal tube. Cut it. They actually is already prepared to paint. And oops, yeah. As you see, even I didn't get the brand name, because that was the brand name from this carpet corporation. Like a stickers on this tube. That's all. I was clean up everything, and that's all. It's absolutely light. That's the most actually exciting thing. It's extremely light. So.
Wow.
And very stable, extremely stable, compared to everything I tried before. It's actually probably the best solution.
Interesting.
Yeah. I mean, same idea is with what they call the wood, actually refabricated wood and plywood and stuff like that. They actually do pretty much similar procedure to create the plywood. They actually wash up everything inside the caustic soda, and after then they push everything together and they create something like plywood. So we already got sort of nano-coated material, basically. That's a kind of laziness from my side.
And it was a live tree at one point too, so keep that in mind
Yeah,
too. So
yeah.
it's
I'm
sort of recreating the tree's spirit in a way.
exactly, and this is beautiful recycling because I mean, if you're gonna look at around, it's thousands of hundreds of empty boxes like that, and people threw to the rubbish, and no one take care about these things. But if you're gonna cut it to the small pieces, and you got fantastic stacker, for example, something like that. I'll show you. It's not the best light here. It's still dark in London. Right. Oh, this is something like that. This is the plywood, basically. Nothing more, nothing less. It's normal average plywood. If you like to, be sure it's nano-coating in the full scale, just input to the caustic soda, but on the spray or something like that in a plastic bag for, I don't know, maybe 2-3 days, something like that. It's gonna be fantastic. And enough. I mean, it's still open because I still unload this stacker with the coils. So anyway, this is something like that. This is the kind of lazy option how to figure out with the stacker. So and my
nice.
question
Is
because
that, do those plates just press on? You can press them off and press them on and access the coils that way if you need to?
yeah, if you like to do it this way, yeah, no
Or you
problem.
could
If
just
you
put a drop of glue in to make it permanent.
I mostly do permanents, but I got one stacker built by from Lego box, and this is my opening stacker. This one is mostly built like a solid state. After when I glued it, it's finished. So,
All right.
and the one thing, I mean, if you guys got some piece of sounding paper with the nano coating material on the sounding paper, it's a good idea. Just put a little bit on the bottom and just leave it here. Even the guns and stuff like that. That's what I do often. I just do kind of mix of the special guns. Every single floor with different combination of guns. Depends of guns on the coil. That's the connection. And I try to always build. So. I don't know how much they're very helpful.
Well, thank you for
actually,
showing that. Appreciate it. It's
welcome.
always good to see some new perspectives on this, the same, the same basic idea that we've been looking at for several years, and now every once in a while we still get a whole new viewpoint on it, or at least a new way of doing it, that you haven't thought of before or seen before. So that's fun. All right. Let's. Anything else on that? Anybody have any questions for Tom on that?
Well, Tom, that's really amazing. We're going to have paper-based spaceships. I love it.
Thank you.
The other question I had was just the glues they use to compress the paper back together. Does that have any impact on it? Does anybody think, or is that do we know? Do they use glues?
You know what? I was looking for a long time how they glued all this paper, but I didn't figure out how they managed to do this. But that's what I do. I do my own glue in every single elements when I need to actually correct and stuff, and do small kind of repair with this cone because they always a little bit disturbed, and it's not the best way how they originally glued all the stuff together. And the best option is always correct once again after everything. And I use the combination, same story, combination of ganses, but this time this is the liquid plasma and just normal PVA glue. It's like a white glue from especially dedicated to the wood, paper and stuff like that. So,
Perfect.
yeah.
Okay, thank you.
Welcome.
I very much appreciate seeing it.
Okay. Let's move along, I guess, to what? Do you have anything else, Lee, that you wanted to show there? Or see, your video's still open, so I'm going to hit on you again if you're game.
Yeah, I got. I've been out talking to a few people about whether they want to buy a car Magrav or whatever, and of course everyone wants to know what plasma is and stuff like that. So far, I've been getting a lot of negative responses. So I was putting a slideshow or a PowerPoint together on what is plasma, and I was wondering if I could go through that and get your opinions on some of this stuff, and maybe you can give me some pointers and
Oh yeah, that'd be a
revise
great
some of the words
idea.
I'm using or something.
Sure, you bet.
Okay.
While you're setting that up, Lee, I'd like to let you know that Jackie's been doing some experiments with her car units. And what she has found when she installs them, if she installs them sideways, so the coils are standing up vertically rather than stacked one on top of the other, she gets a dramatically higher field reading immediately out of the coils.
Okay, so that's a change from before when we said we wanted the magnetical coil up then, eh?
Yes. And she's putting the positive, the magnetical coil at the front. And she's having fairly consistent and really good results configuring it that way. So I think we need to look at orientation of the unit itself, not just the coils within the unit.
Okay. Because I've been labeling mine this side up, the magnetic side up. So I haven't tested different orientations, but.
Well, she uses a magnetometer app on her smartphone, and vertically, the way we typically would do it, she gets readings, 40, 50, 60, somewhere in there. She turns them sideways, the readings go to 300.
Wow.
Yeah, dramatic increase.
Guess I got to get a magnetometer from my smartphone. Okay, so yeah. So anyway, on this, what is plasma? According to Webster's dictionary, there's 4 definitions for plasma. One is green, fairly translucent quartz.
Really?
One is a fluid part of the blood lymph or milk, as distinguished from the suspended material. B, the juice that can be expressed from a muscle. So then there is protoplasma, the organized colloidal complex of organic and inorganic substances as proteins and water that constitutes the living nucleus, cytoplasma, plastids, and mitochondria of a cell. And then the one that most people come up with is a collection of charged particles, as in atmospheres of a star or in a metal, containing about equal numbers of positive ions and electrons, and exhibiting some properties of a gas, but differing from a gas in being a good conductor of electricity and being affected by a magnetic field. So what I've been doing is asking them what they think plasma is, and normally you get, well, most people I haven't talked to me give me definition number 4, sort of, or some version of it. And then I got to tell them none of the above definitions apply to what we're studying here, so we need a new definition. So this is what I maybe need some help on here.
Yeah, by the way, it's a different meaning for plasma for someone who is in biology, and it's a different meaning in physics. Look at the original ancient Greek meaning of the word plasma. That would give you a clue.
Yeah, and if it's then that's a different meaning for doctors and nurses too. They think of blood plasma, so yeah.
Yes, exactly. And we're told by the scientists that 99.98% of the universe is plasma. And we're also told that 3/4 of it is dark matter and dark energy at the same time. The word none is None. first word up in your upper left there.
Okay.
Just a little spelling thing. Okay,
I never could spell. I haven't spell checked this one yet. So, okay.
Yeah,
So
let's-
definition.
we get echo from your thing, John. Thank you. Go ahead.
So the definition I sort of came up with as a start here is one of three plasmatic states consisting of a collection of magnetical fields and gravitational fields of various strengths. Is
What three plasmatic states? I'm confused there. One of the three plasmatic states. I don't
that's the next slide.
understand that.
That's coming up.
Oh, okay. All right. I kind of go with that. Okay, well, depending on what comes next, I guess, yeah.
Okay, so next we go, and everybody knows what the three states of matter are, and some people or scientists now are putting this fourth state of matter as plasma, which is the definition of four in from the dictionary. And most people agree, yeah, that's what they understand matter to be. And now we go into the plasmatic states where we go nano, GANs, and plasma. So now we got 7 states of matter, 2 of them called plasma with 2 different definitions of what plasma is. Now the question is, I got states of existence here. I don't know whether their existence is the right word. I'm just wondering, I was wondering I'd get some input on that.
It does make sense to me. Even a thought has existence, and thoughts are plasma, so it does make sense.
Where do fields come in, or like what about existing outside of, is it possible to have an existence outside of these plasmatic and matter states is what I'm trying to say. Where does the essence or soul come into it, for example?
Yeah, okay. Well, it's
We got to throw that in somewhere if it's a state of existence. But then we have to define that somehow too, because it's interrelated somehow. It's because this plasma on the left side, the plasmatic plasma state, has the fields that are involved there are different than the fields from the any of the other, especially of the matter states, but definitely of the other plasmatic states as well. It's like the high end, or the finer fields, the finest fields actually. Okay. Any other comments on that to sort of help clarify here? Is this complete, or does it need fleshing out? Less, more or less? Hello?
okay. So I could have then I was going to this. Guess I can't go backwards on this. I was going to go, and everyone knows about the frequency spectrum, and how this is sort of a matter state thing with vibrating electrons or whatever, and but the plasma state is different. It's about field strengths, and we have a field strength spectrum that we are just starting to investigate and find out what it is. We got weak fields all the way up to strong fields, and we can convert the weak field states of plasma into matter and back and forth as one of the sort of down on this end of the spectrum. But we really don't know what all the rest of these strengths are good for yet. And that was
Be
it.
nice
So
to-
far, that's all I had
It's
for
just-
my slideshow.
Okay, I see where you're going with that. It's
Now, I
good.
could
Now,
have a separate slide for nano, GANs, and then plasma. And I think maybe I got to put them in there and explain the 3 plasma states better.
Yeah, that would be good.
But I don't know whether I've defined plasma good enough in this slide. Say what I want to do is use these as for a video as well, and use some sort of this voiceover video with these slides and as the pictures.
Okay, how does let me see, how do the fields work into it? How about what are magnetic and gravitational or Magrav fields, or how are you going to work that into your? Because that should be part of this concept of plasma, because the plasma interacts. That's the difference between the plasma of the plasmatic state and the plasma of the matter state. It's an interactive plasma.
Okay, so that was part of my definition. My definition 5 here. One of the 3 plasmatic states, which now you know what the 3 are, consisting of a collection of magnetical and gravitational fields of various strengths. So that's why I had the slide on the strengths there at the bottom, and the that slide. Well, that slide there sort of showed the plasmatic states. And as I said, I probably got to have 3 more slides, 1 slide for each of these states to explain it a bit better.
Yeah, that would be good. That'd be a good idea.
So I'm not.
Okay.
So I would say the nano state would be where we give copper wires. Copper is an example where we bring the atoms, copper is very tightly packed together, electrons flow through it very easily, but in the nano state, what we do is we sort of bring those copper atoms from the surface off the surface and put, they come in with lots of gaps in between them, and now it becomes a superconductor for the fields to flow through.
Yeah, if you can make a basic picture of that, one of the copper, the plain material copper, and then of the difference of what the nano looks like, sort of a blown up view or something.
Yeah.
Just showing the open structure, like Mr. Keshe does all the time. He has the balls put together, and then he has the balls separated apart, and it shows the molecular structure, kind of. Yeah, that sounds good.
So I don't know what else to say about nano. Or maybe that's enough. And then the Gantt state, that slide, that's a hard one to illustrate a bit.
Well, if you could continue with the same type or even the same picture, like your nano starts with the solid matter and then goes to nano with your maybe 2 pictures, say, from one goes to that, from solid to nano, and then with the GANs you could start with the nano and then go to GANs, and the nano is the more open structure than the solid, and then the GANs is even more open.
The GANs is really separate particles, not even
right.
attached.
Right, but you could show them maybe detaching from the nano, because that's where they sort of come from, or maybe you could show them being formed in the fluid. Or in any case, you've got the separated GANs particles at that point. Mind you, it's inside of the other plasma of the water still. Yeah, so...
Yeah, Mr. Keshe is always saying they're like little mini suns, and most people don't know that and wouldn't understand why we say that. What makes a GANs particle a GANs particle? as opposed to another particle.
Well, when I was describing this before, especially to people that are just getting started, I try not to go into extreme detail, and I simply define nano as matter that acts like plasma. GANs is plasma that acts like matter, and they seem to be, for the most part, satisfied with that at the beginning.
That's what I'm looking for, something nice and simple like that.
Yeah. And when they ask, what's, how define plasma, I say we use the term plasma in a similar fashion as the term blood plasma, which is a collection of things. In our case, it's a collection of magnetic and gravitational fields.
Okay.
Actually, this is the best definition. This is the collection gravitational of magnetic fields. It's as simple as that. That's all. Oh.
Okay, so my definition up here, does that sound pretty good to you guys?
It's a good idea. I think it should be rephrased a little bit. Instead of just saying one of the three plasmatic states, try to that could be part of the definition, but it need to like start out the sentence more affirmative or something here. You know what I mean?
Even a rock is a plasma. It's just in a very condensed state. Everything is plasma. Rock's plasma, the sun's plasma, your thoughts are plasma.
Okay, why don't you put that in? Everything is plasma, but but can fall into one of three plasmatic states. And is that true?
Well, okay.
So it is a good point that John made.
I'm thinking we've like we can now. It used to be that we just converted between the solid, liquid, and gas back and forth, and had different ways of studying how to convert between with all the different substances we've had. Now all of a sudden we've got, if you ignore the plasma up top there, the definition of 4, then on the matter state, now you got six things you can go back. What John is saying is true. Like you can, a rock, you can. It is all the, I guess, when you break it down into its finest detail, it's fields. Yeah.
Well, that's the big problem and the big the secret of all this teaching wrapped up in one.
But it's a solid because of.
We could look at a nano material copper plate, black copper plate, and you could say that it's solid in terms of the matter states, and you could also say it's nano in terms of the plasmatic states. And so because it's nano, it has a plasmatic field. But the solid, if you look at it as a solid, you wouldn't think of it as having a field around it necessarily. So maybe that's one difference that can be noted there, that in the matter states, generally it's not looked at as, the fields aren't looked at, just the, and same with the liquid. You could look at some water and say, yes, that is definitely liquid. It's not a gas, it's not a solid. But if it had GANs in it, or if it was plasma water, then it would be a different category. It still looks like liquid, and you could say it's liquid. You could drink it as liquid, perhaps. But on the other hand, it's a GANs in a, or a GANs water, a plasmatic water, a plasmatic, it's in a plasma condition. So this is where the where the clarification needs to come in. It's like the plasma point of view is a different perspective on what looks like the same material. So, I mean, if you look at a fruit or a vegetable, and people would say, oh, that's a solid that has some liquid, you know, mixed in with it, or liquid inside of a solid cover, you know, depending on the fruit or vegetable or whatever. But we might say that it's basically a GANs, you know, or it's the, you know, it's got a nano coating on the outer cover of it, or its skin is composed of different ganses, and it has a plasma field that's encompassing the whole object and even the molecules inside and so on. Each GANS has its field.
I'm
well,
wondering. I'm
that's a
wondering
little.
I'm wondering if a Venn diagram would be a little better representation, where you would have solid, liquid, gas, nano, and GANs, and another one that's not on this list called a free plasma within the encompassing plasma circle. So they could see that plasma is basically everything, but you have these different states of plasma, because you could have a rock, you could have water, you could have xenon gas, you could have nano copper, CO2 GANs, and you can also have free plasma, which is just fields that aren't differentiated into anything yet. They're just fields. But it's, go ahead.
These things could be in one circle, plasma, say.
Pretty
you'd
much.
have
That,
plasma in the
sorry,
center
you're
with the rest of the things circle around it.
you're breaking up there for me, anyways. Could you say that again, Lee?
Yeah, so you could have a circle in the center with plasma, and then you could have the circle of the other states around it.
Oh, it would actually be the other way around. The 5 or the 6 typical states, solid, liquid, gas, nano, GANs, and free plasma, would be in the center, circumferenced by
Okay.
the overall broad plasma definition.
Yeah, and as you move deeper into that Venn diagram, I'm going to bring up something that John said just now, which is the condensation of energy, so to speak. So the deeper you move into the Venn diagram, the less available the plasma state, the less plasmatically available it becomes. So with a full solid, it's not that plasmatically available. But as you move further out into the liquid, the gas, and the GANs, it becomes more and more plasmatically available, and then starts to skyrocket when you get to the nano and the GAN state. So perhaps we should be looking at it from that condensation perspective rather than just what's shown on the screen right now.
Okay. The purpose of what I'm doing here is to try and explain this first to a newbie, someone who has never heard of these plasmatic states before. I'll sort of introduce them to them and give them a sort of a simple definition. This Venn diagram thing I think is great, but is that a little too advanced for someone who's never heard of plasma before? I'm just wondering.
Well, instead of a Venn diagram, you could even have a very linear kind of a representation where from top to bottom. At the top you have plasma, at the bottom you have solid, and in between you fill everything up based on plasmatic availability.
Mm-hmm.
So I think the idea is to get people to realize that everything is plasma. Now, the only thing that differentiates one expression of plasma from the other is the plasmatic availability based on the condensation level of the plasma. So right at the top, you have the least condensation. Right at the bottom, at solid, you have the most condensation, something like that.
So the free plasma would be at the top in that case, or
yeah, that's right.
And if it was in a circle type diagram, the free plasma would be at the exact center, I'm presuming, and then we'd have the solid and liquid would be at the outer edges of the circle, and then the other higher states of plasma, GANs, and nano would be toward the center of the circle, but not at the exact center. Something like that, perhaps.
Something like that. Yeah.
It would look like if you cut a Jawbreaker candy in half, and how you could see all the layers.
There you go. Yeah. So, but which layer would be in the center? I mean, which layer would be in the outer layers toward the hard shell? I guess you think about it, sort of like an egg or a jawbreaker. The outer part is the hard, matter level, solid, shell-like part. But yet the whole thing, when taken as a whole, still has its plasma aspect to it, and fields and so on.
Well, if you were to look at it from a condensation perspective, let's say that the center of something is going to be the most dense. So if we look at it from that perspective, the solid would be right at the center, and the free plasma would be on the extreme outside, with everything else in between, based on the plasmatic availability of each state of the plasma. At least that's how I'm visualizing it.
I mean, maybe the most simple idea, that's one I use many times and often with people when I just chat and show how to build all these devices and how to explain these two things. For me, it's a very simple parallel. It's like a spiral form, that's all. And the gravitation field, the strong gravitation field is your stone. The strong magnetic field is something who was create the stone. That's all. It's kind of simple parallel for these two situations. And everything what's happened between is also plasma too. This is the different state between the something was hanging somewhere in a space and turned itself to the stone. With all the stages between.
I love it. I think that's very simple. It's very, very clear. I love it.
Oh, thank you. The people like it. Everyone got it. I mean, it's not a big deal to understand this kind of things, especially when Mr. Keshe drew many times on the table the spiral form, and when you explained all this parallel between the gravitational magnetic fields. Because for me, it's much more easy to explain the potential of this both streamings. Something go to more gravitational field, something go to more magnetic field. For example, CH3. This is a very good example because it's a heavy magnetic field, and but it's a GANs. So they hold all this gravitational information. It's like both things together. So, and the best option is just like draw the spiral and show, okay, outside the spiral, this is the magnetic forces. This is your emotion. This is the moment when you see this amazing girl somewhere there. And the next things, when you after marriage, when you got your keys and your kids ask you about the key to your car, and this is the other part of the spectrum inside. But this is both same things. This is just process. This is part of the process. We always observe only one single because as life is short and perception, many things. So we always concentrate our attention on sound like a few seconds from 1,000 years of long process. And this is only one problem. When I expand everything, when I translate to someone, okay, just stop, look at the only these 3 seconds what's happened in front of your eyes. Just try catch all the situation. Okay, the stone before be stone, be a piece of dust, space dust somewhere there. Just forces inside the space. We just shape everything. And it's the same like a people. We just born in space and finally landed in this body. And it's kind of I mean, very, very well working for me parallel. Explain something to the people. And no one get big problems and everyone, oh, okay, I got it. Okay, the stone is a gravitational thing. If I'm gonna separate the energy from the stone, that's gonna be pure magnetic thing. When I get stone in my head and hands and I feel something, that's both feels together.
Okay, well, thank you very much. I think that helped a lot. So now I can revise my slides here and be able to tell people about plasma a little bit better. Thank you.
Maybe I could read again the contribution from Alex Skoric, who, when we were trying to define plasma a couple or 3 weeks ago or something, it's from January 3rd, something he wrote. So let me put it up as a screen share here, and I'll just read it through, and it might be inspiring for some of those things that where we're trying to define this whole thing. It's very difficult to define, and Mr. Keshe has done a very good job of doing so, but we also have to redefine it in ourselves, and everybody has to come up with their own definition in a way. Yet we have to have universal definitions at the same time. Let me just make sure that's sharing properly. There we go, I think. And okay, let me just read it. Sure, the mics are off here. Leo, just turn your mic off for now, just for this part. Okay, it's defining plasma. Plasma is an energy state different from what we experience on Earth. On Earth, we experience matter state. Matter state is an energy state at the opposite extreme of the plasma state. There are intermediary states such as nanostate and GANs state. Although the word energy applies to all states, the energies are different with different properties and characteristics. The lowest form of energy is in matter state. Electricity will pass through a wire obeying Ohm's law of resistance. Intermediary and plasma states are progressively higher forms of energy. Electricity will pass along a wire instead. Ohm's law does not work anymore. This electricity now becomes flux lines. An order of magnitude is a difference of 10 times lesser or greater. Nanostate is an order of magnitude greater than matter state. GAN state is an order of magnitude greater than nanostate. Plasma state is an order of magnitude greater than GAN state. All states have flux lines. Flux lines create force fields. The basic forces are gravitational, electromagnetic, strong nuclear forces, and weak nuclear forces. Each force has a polar opposite force for a total of 8 forces. The strength of each force has a range of variances. These variances in matter state are called isotopes. Plasma states can differ, such as a gas in nanostate, liquid plasma, or field plasma. Matter state is planet-bound. Plasma state is sun-bound. Matter state is differentiated. Plasma state is undifferentiated. The same can be seen in cell creation during wound healing. Undifferentiated blastema cells cover a wound and begin the healing process. At some point, these cells become differentiated. That is the difference between toes and a nose, despite the fact that both come from the sun. Undifferentiated field forces come from the sun and interact with the matter state field forces, creating a position of balance. This position of balance is where you and I, as individuals, reside on this planet in a differentiated matter state. We can change the intensity and nature of the field forces. We can go from matter state to plasma state. This is a skill set to learn. We can go from plasma state to matter state. This is a second skill set to learn. Many have conspired through wars, oppression, slavery, mind control, social media, etc., to deny the access to or even the existence of this knowledge. Warmongering cannot survive in a plasma state. Depriving peace is solely a matter state exercise. Therefore, learning and mastering these two skill sets represents the freedom and emancipation of humanity. Alex Skoric, January 3rd, 2017. Thank you, Alex. Once again, that's some good words, I think, to hear. Any comments on that, or anybody take exception to this and think it's all totally wrong or something like that? I'm willing to go for a battle if we need to, but go ahead.
Rick, it's Jay. I posted all that in the chat. I typed it all out the last time. Remember, you showed it before, so it's there for anybody if they want to copy it. It's all in text.
Okay, good. Yes. Thank you. All right, I guess everybody's happy with that then. I don't hear any complaints or comments at this point. Okay, well, let's carry on. Who else would like to show, tell, or do you have another definition for plasma that might help Lee with his plasma report?
Rick, this is Zane.
Hi, Zane.
Wouldn't plasma be the intent of manifestation of magnetic and gravitational fields?
The intent of manifestation, is that what you said?
Right.
The intent of manifestation of the fields.
Yes.
Well, you got me on that one. That sounds like it might be viable. Anybody have a comment on that? I think plasma has been defined once as the results of the interaction of Magrav fields, right?
And it's also been mentioned that with plasma, we are working with consciousness. So being the intent of manifestation seems to fall in line with that definition.
Right. So, can there be what about, can there be non-conscious, unconscious manifestation of plasma? In other words, is all plasma necessarily conscious, or is it maybe just connected in certain ways, certain levels?
No, now we're now gonna be battle. What is the conscious? What is unconscious?
Yeah, right. So we get into some pretty big ideas here, and all of a sudden we get sort of pretty out there, because a lot of what, when we try to define this sort of thing, we start to get into a split. The split happens between the matter level, the matter world, and what we might call the spiritual or field level world. So, and both viewpoints are valid. It's just a matter of, you have to sort of take one viewpoint or the other. It's difficult to maintain both at the same time, because they can be sort of mutually irreconcilable, or they can be mutually exclusive sometimes even. Because for example, if you fall into the normal habit of seeing things from a material point of view, then you'll see a pencil and a pad and a desk and a light bulb and a screen on the computer with different images that seem to make sense and so on. But if one was looking at that same moment from a plasmatic point of view, you would maybe see things in a totally different perspective, in the same way as if we were somehow able to see all the electromagnetic fields around us, we would have a different viewpoint or perspective. If we were able to see the radio waves, all the hundreds and thousands of radio stations that are impinging on our space all simultaneously, most of them very weak, some of them quite strong. And if we were able to visualize them somehow, and that's all we saw, then that would be a different world. And in fact, if you use a sensor and a crystal radio circuit like I've done before, then you can actually sense the fields around you. And if you're right into that and you're right into sensing the fields of everything, then you forget about the actual physicality of stuff in a way, because what you're looking at and investigating and all into is the fields. And that was, that's a different realm. So in the same way, to see things plasmatically and especially on multiple levels at the same time is a bit of a trick, and the trick part is to not get tricked into seeing just the physicality, just the very narrow range of the electromagnetic spectrum that reflects light into our eyes. And that's what we base our whole existence on, which is a pretty thin thread when you think about it. That was you remember in that diagram that Lee showed earlier, the visual part was only a very narrow part of the whole deal. So something to think about. Okay, I'm going to put my video back up here until I can find someone else to put theirs up. Okay, any more comments about that? So part of that gets into another concept of what is real. And another one of, is the world illusion, as is...
Actually, emotion is real.
Pardon me? I think that was Armin. Emotion is real. Okay. And all the rest is BS?
No, it's not BS. It's dictated by... You emotionally can pick up a cup of water and drink if you wanted that. You create that emotion, that motion.
That's a good idea. I'm very thirsty. Thank you, Armin, for that suggestion. See, it works. I went for the matter level. If I was a little more conscious of what I was doing, perhaps I would be aware of the plasmatic properties of the water. And
it's hydrogen that you are holding in your hand.
It's, pardon me?
It is hydrogen that you are holding in your hand.
Yeah, it's dihydrogen oxide, actually. H2O. Dihydrogen oxide. Did you have any dihydrogen oxide today?
Definitely, every day.
And if you're aware how it transforms, I took a drink of water earlier today, about 2 or 3 hours ago. I was very thirsty, and I just thought, oh, really craving water. I need some water, and I found some water and had a sip. I became aware.
Your emotion dictated to you to just go and pick up the water and drink it, correct?
Yes, but I didn't just pick it up and immediately just satisfy that thirst. I actually was conscious of each gulp of water. I held it in my mouth for a while and sort of almost chewed it. Well, I was aware of it. I was aware in that moment of the GAN's nature of water in our body and how it transformed as it came up to my lips and went through into my mouth. And it mixes with the other juices of the mouth, the saliva and all the other breakdown juices and so on. It becomes GANs, and it's no longer water. We don't have water in our body. Pardon me?
It becomes in a plasmatic state.
Right.
body because you have a vacuum state. So, and just it turns to plasma, meaning
Right.
it releases energy to you.
Right, and it really felt like that as I was aware of it going down. I could feel it going down the esophagus, down into the stomach, and so on. And I felt energized by that. It's really satisfied my thirst, as opposed to just being busy with something else and having a quick glass of water and just not even thinking about it. Not even that would be a sort of an unconscious. Drinking of water as compared to being totally aware of its effect and what it's doing and the full
You are aware because you
pardon
are
me?
thirsty. Sure, you are aware. Your body is aware that you are thirsty. That's why in emotions it dictates you to go and pick it up a cup of water and drink it.
Yes,
So
but sometimes we don't follow through with that emotion, I guess is the point. Is we feel it and then we satisfy it by just having a quick drink and away we go. Same with having fast food. Maybe I'm hungry, gulp, 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 and away you go.
But Rick, that's actually 100% emotions. That's the 100% emotions, nothing else. Emotions is emotions. That's
emotions
only
are
emotions.
the physicality what to do. So that's my point.
Right. Okay.
What's
Yeah. It's a good point. Good point. Absolutely. And so,
is your body real?
pardon me?
Is your body real?
Well,
You
this
can
is
feel it, you can touch it, you can see it in a mirror. For you, in this state, is real.
yes,
So your
but
emotion,
wait a minute. I don't trust my senses necessarily that way. That something is
why
real
you don't trust your
just
sense?
just because it's solid doesn't necessarily mean it's all real. Because, like you say, it's the
In
emotion
this
that's
state, it
real.
is. We can see it, we can touch it, we can feel it. In this environment, yes, it is. You cannot deny it. If you deny it, then everybody else going to deny that.
Well,
If I see you,
but
you see
no,
me,
it's not denying. It's a matter of viewpoint. It's a matter of perspective. One can, be
yes, in
totally.
this environment.
What is this
Like we don't
environment?
see
What do you
there's
mean by
life
this environment? What do you mean by this, Armin? You're not in my environment. I'm not in your environment. I don't know what you mean by that.
we are in one environment. We are on this earth.
Okay, you mean under the gravity of the planet
Yeah.
Earth, the
You
gravity
breathe
of the
through, I breathe
situation.
through. So what's the difference? You are in Canada, I'm in America.
Well, the difference is that one can be in a different state even if one is not in America, so to speak. One can be in a different, for example, there are exalted states, let's say, that have been even higher than Alaska. And I felt that the physicality in those states was not important. It's the sensing of the fields, call it feeling, that's what I would call it. You could call it emotion or feeling, but it's not the emotions of, oh, I'm hungry, I want this, and so on. It's more like feeling the immensity of the emotions of the universe at that moment, and so on. Not so much the little gnawing things we call emotions that are often just hungers and thirsts and so on, but more larger emotions for larger feelings and feeling fields rather than looking at matter level stuff. I got a lot of stuff around here. It's all, I could see it all as matter level stuff, or I could have a viewpoint, if I so choose, to look at, okay, what can I work with plasmatically in this space now? And I might go for certain nano-coated things and be able to arrange that to develop some sort of plasmatic structure or something if I was focused in that direction. Pardon me?
Look, you're mixing both together. You are mixing both states together. I am just saying, as an emotion in this physicality, in this environment, we all look like the same as a human. You understand? Where we breathe, which part of the, on this planet we are from this planet. We're made on this planet. So what I'm saying, on this planet, emotions are in a higher state than a physicality. Even in your brain, you do millions of, processes a day, a second, but you don't feel that. Just imagine if you can everything what your brain is doing. You'll go crazy. Like you're saying, yes, you don't feel it, you grab it, a glass of water and drink it, because it's already in your emotion to do that. You know it. When you get up and go to work, it's your emotion which dictates you to go get up and go to work, because you need to feed yourself. Because if you don't go and you stand up and you sit in your car and drive it over there, you're not gonna get it. So in this physicality, what I'm saying, it's the more emotion which dictates everything, which comes from the soul too. Actually, direct source is the soul. But your emotion, it's your movement of your physicality. What you emotionally want, that's what you're doing, correct? Like to do workshops, and hours you're sitting in these workshops and talking with each of us, because your emotion dictates you need to do this. You love it. You're doing it with your passion. But just imagine you are very down and you are sick, or something happened. You don't want to do anything. You close yourself right away in a room and don't want to get out even. This is this is what my opinion is. So.
Well, it's a very simple way of looking at it. Basically, yeah.
We complicate things. If you want, I can complicate this.
Well,
better as you like.
Well, we were talking about plasma before and trying to sort of tie it into well, the idea came up about consciousness and about is all plasma conscious and this sort of thing. So we were kind of working with that idea for a while there.
Yeah, the consciousness, I think what how do you understand consciousness? Or be aware of what's happening?
Being aware of being aware.
Define.
Being aware of
Okay, what's
being
happening?
aware.
I understand that, Sandro. You explained it simply, just being aware of what's happening.
Your audio's fading there, Armin. Maybe get a little closer to the mic.
Okay.
Thank you.
But now it's good.
Yeah, way better.
So if you are aware, you are conscious. Do you think souls, they have consciousness?
Yes, I do.
Okay.
I believe a soul is conscious.
Explain, please. I want to understand your opinion.
Well, my thought process is the soul holds everything from the matter to the plasma. That's where, let me ask you this.
Yes, correct. You are correct. Go ahead.
So within the body, our DNA, which holds consciousness and plasma at the same time, that's the interaction between the real part, or I don't even want to say it's real. It's like, because dreams are real. How do you explain a dream? It's just as real as you look at in the daytime. The dream is in the nighttime. So how do you?
There's actually some, I was going to bring that up earlier, there's some cultures actually that to them, the dream world is the real world, and what they see in the daytime or what we see around us normally, they call that the world of illusion. And that the real world is when they go to sleep, the so-called dream world. That's the real world, because that's when they're really working with on the emotional level, actually.
And I believe that I would think
you're not operating your physicality.
no.
Right.
So I think that the operation there comes from the soul part of our being.
Well, that's the thing. That's why they call that the real world, because that's when you park the body. You park the body. That's the number one thing if you want to do remote viewing, or if you want to be a shaman, or if you want to be a medium or a psychic or whatever. You learn to park the body. The body, the physicality, in effect, sort of goes to sleep or is subdued, and the spiritual part, the fields, become predominant, become the active part. But you have to make the normally active part, the body wants to go, do. And when that gets settled down and the mind calmed and so on, that allows allows the theta brainwave state to occur, for one thing, and theta and deep delta and bit of beta and so on, or not beta, or rather alpha, and to avoid the beta brain, which is the busy brain, all the thoughts and conflicting emotions and that kind of thing that's not coming from the spiritual level, that interferes with the ability of the spiritual level to operate. It's very easy to, even though it's the spiritual level strong, it's strong in a different field strength, and it's easily overwhelmed by the physicality doing its thing. It's normally hard to meditate while you're downhill skiing or driving a vehicle and so on, although it is possible to do.
But maybe this, sorry for both of you, I mean, maybe this idea, and that's my point about, as we say, Rick, about the dream is one state, the reality is one state, but actually this is the modern anthropological idea. They just didn't get it. The one thing, if someone like a shaman or whatever come to this outer state, they didn't come to like a separate reality. Is only one reason, to pick up the bigger perspective, because everything is made by these invisible forces, by plasma. We call this plasma. This is the invisible forces made by us amino acid, emotions will do these emotions. And inside the state, you just got the bigger perspective. It's like go to the most higher mountain in your area, and you see all this land, vast land. This is the most higher mountain, and you go to there. That doesn't mean it's not physical or is unconnected or something like this. This idea for duality, this is actually illness from West. They didn't get this idea. They actually think, okay, the dream is a different state, the reality is different state. But what's happened if in your dreams you got straight information, like millions of people all across the planet, about your current reality? So where's the transition point? So that they does exist. This is the same reality, but the one thing is maybe for this moment some, I don't know, metaphorical for many people. They don't get it what's happening inside the dreams, but the other thousands of people perfectly know how to use the dreams, and this is like a heavy base for your everyday life. And if you got some seriously dreams, you know how to manage this other part of the process, what we call physicality. This is just the next part of the process. When we concentrate our attention on this symbolic 3 seconds, or even gonna be dream, even gonna be reality, we didn't get the point. We need to actually stretch this field and just, okay, the dreams and reality is like a same thing. This is the information, this is the pure information. It's not unconnected, it's fully connected to us body. Everything is connected, everything. By amino acids, by everything, basically. Only we like to see dreams or something like that of altered states, like something states like I don't know, separate things, like one mechanical clock from us brain and pull some different direction. And after when we try to wake up, this part of mechanism back to again to us brain, and we able to wake up and go somewhere, do something. But this is only this cultural point of view. Normally, this point of view does exist, because when you wake up after a heavy dream, you're looking for correlation between the two states of reality, because they always, and this only depends on us, we blind or not. That's how I see these things. I mean, I didn't see this kind of difference between the dream and reality. It's the same thing. The one thing is just pure information disconnected from the body, and we don't, not everyone, but many of us get sometimes problem with use this information on a daily basis. That's only one problem. And that's the reason why we try separate the states to, okay, this is different me, this is different me, this is different me, this is the different me. No, there's only one you. That's this is the only point. How far you see? How far you see? Do you see only these 3 seconds, or you see only next 300 years, or 3,000 years, or 3 million years, or you see far enough to discover the reality is unlinear. It's not like a linear point after point. It's just like a space. This is just us point of view about reality. That's the reason why I think sometimes we get massive problem with pick up a few things together and make them work. That's the only one thing, because we don't like find the simplicity between these many things, or whatever we're gonna call it, the different states of mind. There's still one person behind.
Okay, thank you, Tom. That's good to get another perspective. Anybody else want to chime in about that? Hello? Anybody out there? You see.
Well, that's the problem with all these heavy subjects. We all sit here and ponder.
Yeah, it gets so heavy. You know, that's why we need levity. Levity is the cure for gravity, you know. So you can quote me on that. I think I got a laugh from someone in the background there. Anyway.
You got it from me, my
I thought it was you, Libby. Thank
I
you.
love it. Levity
Thank
is.
you. I could use a laugh track here. That would be good.
There you go.
Like that. I need a t-shirt like that.
All right. Anybody else have anything to show and tell today? Wondering what topics that might come up that we could penetrate a little more?
Well, I don't really know if I can do a show and tell, but I have such an incredible reaction with after watching that elephant foot picture.
Oh, that was weird. Yeah.
It was, but
well,
you know,
tell us what do you mean?
Well, because I've had this lesion on my nose from a cat scratch, as you may or may not know, for 9 years, and it's gotten worse. And I thought, wow, I was very apprehensive about using large amounts of copper oxide water before. And I thought, get over this, because that's what they're using with zinc liquid plasma. And you know, it's drying up. It's whatever was in there. You know, I don't do medical doctors, so I haven't had any kind of medical opinion, except one doctor saw me at a party one day and said, "Oh, you should go see a cancer surgeon." But anyway, so I don't want to do that. But it's drying up, whereas before it wasn't doing it at all. And I am recording it with pictures. So I just want to tell people we have amazing things, and CUO, liquid plasma.
Okay.
Yeah,
CUO, liquid plasma. Not,
and
no CO2 or zinc oxide as well.
Yeah, and my roommates are noticing the difference. It's just wow, because it was getting really raunchy. It's right in the front of your face. You don't really can't hide it. Not that I
Hmm.
wanted to hide it, but I did want to heal it. And I've been using a lot of CO2 and zinc. But if it is a parasite, which could very well be, I needed to give it that real good kick. And do I want to do a show and tell? Not yet, but I will do the pictures, and
Yeah.
I'll be back. But
Yeah, it would be good to record it with pictures and, so you can document that for sure.
absolutely. So that's the advantage of watching and participating in the Keshe Foundation workshops, is that you do learn. I mean, it's so exciting to see the difference for me and my own hesitation, because I understood that copper oxide, or Cu, is copper oxide the same as CuO? Am I referring to it correctly?
Yeah, that's right.
Okay.
Hmm.
Okay. So initially we had been told, and I understand we do need to be careful with it, but I had taken it to the extreme and was just using minute amounts. And this is a 50-50 mix of liquid plasma, um, CuO, and liquid zinc oxide. So,
Okay.
so that's
The
my
zinc,
story to tell.
the
Yep.
zinc oxide again is just the liquid plasma,
Liquid
or
plasma. Yeah.
hmm.
Yeah. Yeah.
Interesting. Yeah.
So,
Yeah, that sounds about right. It seems like many people have had, it's semi-miraculous recoveries or results from those GANS water combinations.
yeah. So thank you to everybody, and thank you. That picture was really hard. Those pictures were really hard to look at, but boy,
They
they
were,
woke me up.
yeah.
Woke me up. I
Yeah,
said, "Ooh."
each one, Mr. Keshe was sending them to me, and they would take a long time to load up, and I'd be waiting and waiting, and all of a sudden this picture would pop up on my screen. I go, oh my God, I'm going to show that? Oh, well,
Well,
let it go.
this,
And then the next one would be worse, and then worse again. I said, no, I can't get any worse. I got worse again. Yeah,
well,
so,
yeah,
but, sometimes we need a bit of a shock like that in order to make us realize, wow, this is number one, really going on in the world, and number two, that there's possible to have a solution, literally,
yeah.
for the problem, and
Well, exactly. And of course, none of us wants to believe we've got worms coming out of parts of our body. And I certainly didn't want to believe that that was a worm in my nose. But the pictures of the round cells with the thing coming through, that sure looked like what was going on in my nose. So I thought, well, bite the bullet, girl. And
yeah, yeah.
yeah,
Well, parasites and bugs of various types are actually quite prevalent in our human organisms, and many of them are actually they have a job to do, and they do it fairly well. But we can be over infested by the little buggers quite easily, especially with the North American diet and so on, with the high sugar and high carbs and whatnot. And it turns out that many of the of the numbers of organisms inside of our body, the way it works out is I think it's 95% of the numbers of organisms inside of our body are not of our own DNA. So only 5% of the numbers of organisms in our body are of our own DNA, which ends up to be about 95% of our body is actually our own DNA. Only 5% is other things. So, but even 5%. I mean, if you weigh 100 pounds, that's 5 pounds. You weigh 200 pounds, that's 10 pounds, and so on. That's yeah, that's right. So, which is significant. Walking around with 10 pounds of other than your own DNA inside your body means that a lot of those things are little critters that you could probably do without and be much healthier from it.
Well, the origins of this lesion come from a cat scratch too.
Yeah,
So,
cats are
add that into there and,
yeah,
it
and
did take a long time.
cats are known for carrying the stomach ulcer virus, which is the Helio pylori bacteria. It's actually a bacteria, not a virus, rather.
Okay.
And this is what's found at the site of stomach ulcers is the Helio pylori bacteria. Now, not all people that have cats get the stomach ulcers. It's not a direct relationship that way because most people have a natural resistance to these bacteria. But it's known that cats carry it, and you can actually get the bacteria from cats if you're susceptible to it, and so on, as well as other things in the environment besides cats. But for years and years, they didn't know that it was a bacteria because the scientists and doctors who are so knowledgeable never would believe that a bacteria could possibly exist in the low pH, hydrochloric acid of the stomach. There is no known bacteria that could exist in that high acid level. So therefore, it couldn't have been a bacteria that is in the stomach. So therefore, there's no sense trying to come up with any solution that's bacteria orientated because it can't be a bacteria. Well, it turns out it is, and it can live in the stomach lining, and it's a crafty little bugger that's able to secrete. It's really quite interesting because it creates its own plasmatic environment around itself. So if you can imagine, I'll say this was a stomach and the little bugs inside there. Well, where it exists, it creates a bubble around it of alkaline to offset the acid, and the alkaline reacts with the acid and is able to create a normal environment inside of this alkaline bubble for this bacteria to exist. Very clever, very clever. And
I also, sorry.
so that ends up causing a great deal of pain and distress for many people of the world and so on until they figured out they have some drugs now that can actually treat it. And there are other naturopathic ways to treat it as well now that they know that it exists in that form. Anyway, go ahead there.
Oh, well, I just wanted to add that, this lesion grew over a 9-year period and it seemed to be better than go back off and go back, but it was a very slow process. But what I did notice is that if I put any kind of oil in it, it would get infected, but not in a good way. And so most healing remedies start with a base of some kind of oil, coconut oil, whatever.
Right.
And it
Yeah.
it didn't work the way I thought it would. So I had to learn. I even had CBD oil at one point, and it too didn't work.
Right.
So that's when I realized, wait, this isn't not that virus or bacteria. This is something very different. And that video, those pictures, just like, oh, okay, wow, those little quote unquote pimples, they weren't even. They're just like raised skin things. I was like, wow. So not that I want to freak out people, but to me, it was amazing to see this. And I'm just grateful again that what we think is something could so very well be different than what it is. And thank you for everybody's support over the years that have made suggestions to me. But I think we finally found the right one.
Right on. That sounds very encouraging.
Thank
Keep us updated as things go on.
I will.
I was going to try to show those pictures, but probably I won't because I can't find them here for some strange reason. I think it's probably a good thing.
Yeah. Early morning.
I'm going to shock our audience here, but they're probably shocked enough as it is. All right, so let's carry on to whatever the next great subject is. Mark, I saw your video on there for a bit. Do you want to do a little show and tell for this week's episode, or What you got going there?
You know me, I always have stuff going.
Right on. That's why I like to rely on you to give me some images that I can highlight here, which is always good.
Okay, no problem. I'm always glad to contribute. You know me, Rick.
Yeah. Well, I see your lab there, as usual, looks very clean and tidy. And what do you got happening there now?
Well, you know, just a follow-up. This week was all follow-up stuff. So on my Gantz production, get up here. Gantz production over here, because this was my fourth run, and this was the run with magnesium and potassium. So it looks a lot different than all the other ones before. It's a little bit clearer, but it's now actually, I started it on 1,917, and it's making GANs. In the beginning, it wasn't. I thought, oh, maybe it's not doing what it's supposed to, but now it really is starting to make a little bit of something down on the bottom. So, like Mr. Keshe said, you just kind of have to hang out and let it wait. You got to, because I don't use any electricity. There's no electricity. You know that, Rick.
Right. So, and these ones have no salt, no sodium chloride. Is that right?
Well, I didn't use any sea salt this time. It's just...
Right. So potassium chloride, is that what you used? And
yep. Good old Epsom salt and potassium.
Epsom salts. That's magnesium sulfate. So magnesium sulfate and potassium chloride. Or potassium gluconate. Oh, okay.
Yep. It's a little purer, they said.
Okay. I'm not sure what gluconate means.
I guess it's just the...
what does it say for ingredients on that? Can you read it? Or
on the...
or is it in too
it just says potassium from potassium glutamate.
Okay.
That's it. So I don't know what glutamate means. Maybe it's just... I asked the guy at the health food store, I asked him, I said, is it the purest form of potassium? He said, that's the purest I could give you. I don't know where else you could get potassium from. So I said, I'll take it.
It was a very good salesman pitch.
Pardon me?
It was a very good salesman pitch.
Was it? So it's no good?
Saying that it is the purest form of potassium is the best salesman pitch. Actually, it's a compound. It's an organic compound.
It's probably the best form for getting it into your body, I presume, is what he meant.
Sure.
But it wouldn't be a pure form of potassium itself necessarily. And the same as, carbon dioxide is pure, but it's not a pure form of carbon.
Yeah, purest potassium, it's an alkali metal, which you have to keep in kerosene, because if it is in contact with air or with water, it burns instantly.
Well, I don't think I don't know where, but anyway, but this is what I bought. And so
it's okay to have a little potassium there. It's a potassium chlorate or potassium hydroxide, which Mr. Keshe used to recommend. It's a product called no salt. It's a salt without sodium.
Right. So, but what about the magnesium in the Epsom salt? What is that in this? Is that any good?
That's magnesium sulfate. It contains sulfur.
So
it depends what you want to make with it.
Yeah, I think it'd be very
sulfur is not the best for nano coating.
Pardon me?
It depends for what you want to use it, because magnesium sulfate or Epsom salt contains sulfur.
But
if it's no problem, the presence of sulfur, you can use it, of course. It depends what you want to do with it, what you want to achieve.
I just wanted to make a Gantz of it. I don't know what I'm going to use. What do we use? I mean, we have certain purposes for certain things, but I just thought that,
I always wonder what magnesium sulfate would do to make GANs with it. So thank you for doing that experiment for me. And that's I still want to do that. What
You know,
concentration did you use? About the same as the regular salt, and about 100 grams per liter or something like that, or?
well, there's 3 quarts. These containers are 3-quart containers. So I used a cup and a cup 1.2. So it's a little bit more than a cup, which is, you know, I got it. Let's see here. Oh, I have it broke down right here. Hold on. So
it'd be about 0.4 cup per liter. I'm not sure what 0.4 cup is in grams or.
it's let's see,
liters.
cups of Epsom salt, which is 40. Let's see. Equals 12. I don't know what that meant. I figured it out, and it actually worked out to what John told me to figure. You know, it's
Yeah, Rick, that works out to 100 grams per liter.
yes.
Okay. Yep.
And then with the potassium, I did it a 1 to 5 ratio, or no, that's a 1 to 10 ratio. But then I broke that down and I put in for the potassium, I went 5 teaspoons, which is there's 48 teaspoons in a cup. So I put 5 teaspoons of potassium, which is I think that breaks down to like 1/10 of the 1/10, if that makes sense.
Right. Yeah. Okay.
So this was just something I just thought I'd throw together, and it's up for 30 days. I make my 30-day run because everything else is made in 30 days, and it made nice scans for all the other stuff. So
And
I thought, what the heck?
how long has it been running now?
One night,
Week.
one
One
nine.
night. Okay.
Yeah, 1/9. So then on the end down here, you know, I started making some silver, and that's been on since the 1/9, and it's starting to make some nice silver gants. But then next to it, I talked to John. I said to him, I go, I bought a piece of copper oxide or a copper ore, a piece of copper ore and a piece of iron ore, and I put it in a sea salt solution, just the 2 of them connected together with a piece of nano wire, and by gosh, it's starting to make some stuff.
Saying copper ore. Okay. Like
Piece of copper ore.
kind of a bluish looking substance, perhaps.
You want me to get? I can put the
Yeah.
camera up.
Sure.
Let me
If you
see
could
if I
show it. And then
Yeah.
iron ore. Okay.
Iron ore, yeah. Pure ore. Well, John said there's all kinds of impurities in both of them, which would be probably crystals. So I don't even care about it's. This guy who's a geologist said, "Well, you should buy this and this." I said, "Oh God, I don't care." He was a stone guy. I said, "I'll buy it. I don't care." So I bought it.
Yeah. Well, that's a great experiment, actually.
Can you see it in there?
I see one of them at least. Oh, I see the other one. Yeah, yeah. So, geez. Is that which one's which there? The one on, yeah, what's that one?
That's the copper
Okay.
ore. And then this is the iron ore.
All right. The copper one looks kind of bright, almost gold.
And it has stuff all over it, gants all over it. And the second thing is can you see the
Is it greenish? Is the copper one a little bit greenish, or is it looks sort of more gold or brown?
It's more, from this point of view, it's more bluish, if you ask me.
Oh,
But I
okay.
think it's because the white, or you know, like how copper turns a little bit blue.
Mm-hmm. Yeah.
And but the thing is,
that's the way it would normally be, I think, in nature. Yeah, we wouldn't be as a shiny copper. It's never found that way. It's always as a oxide ore.
You can see this one next to it right here is copper and copper nano coated copper back there, and it's, see how much bluer this one is. This is just pure copper and nano coated copper on the backside with a piece of carbon rod, you know, for
Well,
the.
you know, this is actually pretty revolutionary. This idea of using the ore, and if it's true, if you can use these two ores and simply connect them together with, you know, something, or just have them touching each other, perhaps is all you need to do. Or maybe bind them together with a string and put them in salt water, and bingo, you start creating GANs. Well, think of this. This is big because we've only had the refining of metals to give, you know, steel and iron and copper and so on in a very limited part of mankind's past. But if ores were to be used back in the good old days of the cavemen and beyond, then that opens up the whole possibility of creating ganses from the ores directly and not having to use the refined metals the way we do now. So that's actually, they may have had various health concoctions and healing pads and whatnot, you know, right from day one, essentially, by picking up rocks laying around in your vicinity. You might be able to come up with a combination that of the right kinds of ganses if you knew what you were doing. So this is actually quite revolutionary in my mind. That could change the past of mankind.
And the second thing is, I got the flashlight on it. Do you see the swishes on the sides of the container? Almost like the fields are coming off the copper and going this way. It goes from right up here and just everything goes this way. Like everything's
Right.
being pushed in a probably in a counterclockwise direction. I don't know, maybe it's because of the air tube, more than likely, but it's just
Or
pretty cool how the GANS is starting to collect on the side.
it could be. Did you nano coat this container previously, or have some sort of process like that? Because
Oh,
maybe it.
absolutely.
Yeah,
You
I
know
thought
that.
so.
Oh,
And
yes.
maybe it was the way it was nano coated. Put that swirling pattern on the inside of the cup to start with, and then the GANs tends to stick to it in that pattern, kind of. I don't
That could
know.
be. Who knows? It's
It'd
just
be
stuff.
interesting. You could reverse the positions of the two pieces and see if that changes the field. You know, changes the way the lines go. See if they go the other way.
Oh, I think maybe if I just took the air hose out and put it on this side instead of this side, and maybe it
Okay,
would make the direction go that way. Is
maybe
what it
that's
looks
all it
like.
is.
Yeah, it's. I think that's just the flow of it, because I can see the tip. You know, the air tube is right here.
Okay.
You know what I'm saying? So it looks like it's, you know, but actually this thing makes fields on everything. This part goes straight down. All this GANS that's being collected on the side is going absolutely straight down. And then from here, the direction of what's collected on the container starts to go this way, from the top down. Now, if I rotate it, keep on going, it's still going in this direction, so that it wants to go to here. It keeps on moving to here, and now it's all the way to here. And now it's actually just stopped. Oh, I just popped the hose. Oh, that's okay. We're having an experimental, because now if you look at the ore, everything here is straight down to the ore. Everything that's collected on the side. Now, if I keep rotating it this way, now do you see the direction going this way towards the ore?
Yeah. Okay.
So,
Well, you have
now
to.
see, so from this side, everything's going this way.
Mm-hmm. Well, you have to
Why?
see if it's from that hose or not, the air hose, I guess.
I think it's just absent. Well, I have other proof, you know, over here that now that I've observed other things, the fields that these things produce are incredible. Absolutely. And there's no doubt about it in my mind that all this stuff has absolutely direction. And my next experiment I'll show that to you if you want to move on from here. If anybody has any questions about GANs, you can go ahead and ask me. This is just fun stuff for me, so go ahead. I've got to have a drink of water, if you know what I mean.
We discussed that with Armin earlier.
Okay, well, if there's no questions, we'll go to the ice.
All right.
From last week to this week, I think I learned how to shoot it a little bit better here so that we can get a better view about it. And what I did this week from last week is I let it thaw out to to water again, to distilled water, to where it was liquid, and then I let it freeze. But what I did was I added some GANs in the bottom, and now you can see it. I'll show it. Let's get it set up here. That's a little too tall. Okay, how does that look?
That's gorgeous.
Okay, it is
Yep,
really
good shot.
beautiful. Just get out of the way here a little bit. You can actually see the different fields. This time, the second time now, it formed exactly the same way, but in a perfect direction, if you know what I mean. It came out from the mini Magrav perfectly. It has a dome on the top here. If you look at the ice, if you can see my hand here, let me go up a little bit higher here. Or maybe I should shoot it a little bit higher, just to give you an effect of the dome. That it pushed out on the top, because that's the arch. Can you kind of get the effect of that?
The dome quite well.
So you know that, and I thought, wow, look at how the ice is forming, or the camera really doesn't pick it up here. So now let me try a couple different lighting.
The camera picks up pretty good. It looks sort of like a saucer shape, actually, with the dome on top and those lines, the multiple lines like that. That is definitely in the ice. It's not in your container, correct? The the horizontal lines that we see, like the it looks like a shell. There's what, 1, 2, 3, 4, 5, 6 or 7 layers, you might say.
On the bottom, down here, the bottom rings.
Yeah.
Yes, those are whatever. I don't know that word, but
concentric.
Yes,
circles.
all the way around. So if I turned it all the way around, you would see those layers on the bottom. They're not on the top; they're on the bottom. Like it's
right. Well,
it's actually.
We were trying to figure out before whether they were created by the cycles inside the refrigerator. So it'd be on for a while, off for a while, on for a while, off for a while. It might create different layer effects like that. But I don't know. It's interesting to think of it in terms of fields as well, because it's...
I don't think a refrigerator... Well, I mean, even if it did do that, I mean, there's actually direction coming. I got a couple of different ones I can show tonight now that I can tell you. We can try to discuss how they're coming in, or I have some that are actually, you can actually see the bubbles that are being stretched in towards the center. But this particular one, the bubbles are being actually pushed towards us.
Pushed out, yeah. You can see the little bubble ends there toward us, like you say, at our end, right? So that's where the bubbles end up, is toward us.
Yes. Yeah, exactly.
And so some of these bubbles are going from the middle of the container right down to the bottom. Is that true?
Oh yes, they're starting from way up there and coming way down here. They're probably stretched a good 3 inches from there to there. I don't know, maybe an inch and a half, maybe 2 inches. Because here's my fingers. So
Yeah.
let me get the
Well,
ruler.
yeah, significant distance for a bubble to travel in there.
Be
That's
pushed that
kind of
far.
bizarre.
Well, this cube is actually 2.5 inches, 2 and 3, no, about 2.5 inches. But the dome is actually 3 inches tall from top to bottom. So that's beautiful. Here, I was going to show. Let's see if we can get a little bit light through it.
Mark, you mentioned that with this iteration you had GANs at the bottom. You mean it was sitting on a GANs pad?
I actually, John, just dropped a
Okay.
little bit of GANs in each one of the middles.
Oh, okay. I was just wondering if the fields were trying to get to the GANs, and that's why we see that cascading effect.
Okay, now can you see from the bottom here how the projection of the ice is going from the bottom? See, now if I'm looking at it here, the bubbles at the very beginning here are really fat. And as they go towards the Magrav, the mini Magravs, they get thinner and thinner and thinner. So that tells me that look at this one right here, how it pulled itself from the bottom towards the Magrav. It actually takes all this energy from the bottom here and starts projecting it through the ice. Does that make sense?
Yeah, I can see that. I would think if that was the case, if you had just a plain water, a second container underneath that, we would see the other side of the fields. We would see the collapsing side of the fields where the bubbles would be formed and pulled in towards the center.
And that would be really interesting to see.
It would. And that's the top of it. Okay, so let's go to cube number 2. I didn't mean to bore you with this. We've seen this.
No, it's not boring at all. I think this is really relevant. Thank you very much. And thanks for the excellent pictures as well. Thanks for setting that up and fiddling with the light and so on. It helps.
Let me dry my hands off here. This is the carousel.
Right. So there's what, 5 or 6 of the little canisters?
Now, let me just explain this, because this is the bizarrest thing I've ever seen. And it's actually done something that so this was on the middle core. I have a central core with wires that spun on the motor. So each pod is connected with a nano-coated wire to that outer ring on the outside of the center core. It's just hot glue to the center core. The center core never froze because of the caustic in the middle center core. If you can see, there's a couple of different things that went on here. There is a middle. It's not frozen in the middle. See how yellow it is? Let me get a light on it.
Yeah, we can see a distinct cylinder down the center of that, certainly.
And if you look closely, there's an outer barrier that stopped these bubbles to get to that center core. There's a center core, and then I can see, I don't know if the camera's picking it up, but the bubbles if you see how the bubbles are elongated, they didn't come from the outside or from the inside. They're trying to make their way to that middle. They're being pulled into that middle. All these top bubbles here are trying their best to get to that center core. And that center core is actually stopping it from, there's like a field that won't let these bubbles go any farther. If I spin it, I don't know if it picks it up, but can you actually see that centered core? How there's all the way, it's perfectly, my hand is getting wet here. I don't want to get shocked.
You can see how the bubbles stop for sure at a certain, like a Coulomb barrier, you might say there. And it's still frozen beyond where the bubbles stop, right? But it's not frozen in the core itself. Is that the way it goes?
Is that a better light?
That's pretty good. Yep. Nice.
So if you look down here on the wires, does it pick that up?
Oh, that's really interesting.
Do you see how the bubbles just look down on the wires, John? The air, I don't know how it did it. It just exploded like the wire off the wire, if that makes sense. There's like 3-inch, there's maybe a 3/4 of an inch bubble off the wire that's actually spiraling.
Yeah, you can see the spiral there. I was going to mention that. It's really cool, actually.
So that's a field in itself.
Mm-hmm. And you can see the spirals coming off the top of the doodad that the wire's attached to as well on the bottom there. And it's like the whole thing is swirling like it was like smoke off of incense or something. It kind of swirls up into the other one.
Exactly. And it's on every single wire. Let me just spin it.
Yeah, let's show some other ones.
No. You know what? I have 2 wires that had one had
go back.
Yeah, go back for a second there. I think we saw something on the wire at the top, right, John, or what?
Yeah, there's a reversal of the fields on the wire on the right-hand side of the picture that we see. If you turn it counterclockwise about 20 degrees.
The other way.
Keep going, keep going.
Keep going. A little more. A little more.
You just start.
Just a little bit more, yeah. A little bit more. Not sure if it was beyond that or if that's sort of it there, yeah.
You can start to see it there.
So up around the top part of the wire, you mean?
Hold on, let me get the other light.
We could see a bunch of, like this part here is interesting. We have bubbles that are actually going completely crosswise. Kind of lost it there.
Yeah, there was one point there where you could see they made a complete loop or a U shape.
You see some of them here too going crosswise, cross-linking kind of.
Hold on. Can't, I know what you wanted to see. I can see it clearly right here, but
yeah, there was one spot on the other wire, on the wire on the left-hand side that when you hit it, there was one spot there. It was just crystal clear.
Let's check out the other side.
Oh! You had it. Back. Keep going. Right there. You can see there's a reversal there's a curve.
With the camera, yeah, okay. Whoa, that's a strange little, that's a strange looking configuration there, eh? Where the wire goes through.
See it coming right off the wire?
It's
It
like
looks like it.
it looks like well, it looks like a what you would call a plasmatic field, and it's a type of plasma turbulence you would see in a like a accelerator plasma or something when they do these simulations. It seems like they have filaments. It's got the bubbles make it look like plasma flux lines or filaments coming off.
That's a good that's a good shot right there.
Yeah, hold that for a second. I'll just get a screenshot of it.
Is that better?
It's pretty good, all right. Yep.
It's just absolutely defining what this will do. It does what it wants to do, and actually, what we're seeing is, that it's just beautiful what it's coming off on that wire. But the central core is really more was more exciting to me to see that it actually made that core how dense it is in the middle. Why did it protect itself in the middle like that? You know what I'm saying?
Well,
All right. Well,
yeah. Well, good question. Makes sense. It's always the middle's usually the last to freeze, but on the other hand, if you have something that's copper there, you'd think it would tend to freeze probably faster rather than slower. And well, you had the caustic in the very center core, though. We have to remember that. So that was able to keep a little heat in there, perhaps for maybe a period of time.
So, dun, 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 dun.
These shots can only go so long, and it's hard under the hot lights of a
So
studio.
this one, I can't get it out of the jug. I got to keep getting it wet because it'll frost up. But now we can actually see this thing split. This is just those little pods of GANs in distilled water. This thing split right down the middle, even Steven, and it just had all kinds of fields going on in it. I don't know if you can see it or not. Whoop, pop she goes. And it made itself a central core. How in the world? Well, we learned that the last place it would go, but when you freeze ice like that, I don't see how you could just, because this thing is, it's split right down the middle. Even Steven. And that's lead right here.
Yeah, I noticed the field shape is a little more chaotic than the other ones as well.
So I don't understand, the GANs and even GANs by itself, these pods are connected to each one of them in the field. And these are outbound fields. These aren't inbound fields. So once again, they made a central core. It made itself a central core. And if I take the top off, it made itself a little dome, its own little personal dome, because it's happy. I don't know if you can see that, but definitely right here, you know, it's way down in the bottom here, but right here in the center, it's almost to the, you know, like I can touch the center and then it'll go down, way down. So it actually pushed itself, you know what I'm saying? It made itself a little top. Now, probably water would do that anyway, but I just thought, how in the world could, you know, CH3, CuO, and CO2 with a little bit of lead on the bottom make that? It's hard to see because it wants to keep freezing. I didn't know how to get it out of the container unless cut it. It was only 99 cents, but I thought that was cool too. So anyway, now this stuff has convinced me that there's actually, these fields are actually made. So that's what I told you last week, that actually helped me to change my design in my bigger, my unit here. So I can explain this a little bit better, because this week I finally got enough work done so that it made me change everything. These are the exact same thing that we just seen in the ice that has that actual field that once this goes into operation with all the GANs together, now I know why the two outside rings were needed. Old rickety rack here needed something to collect the fields, and something needed to make the fields. And in combination, if you just could imagine, this is going to make an outbound field. These are collecting fields, and these will be, the collecting fields will be connected to the center rings. Each platform has its own figure 8 configuration. Each platform has its own arm and motor, or arm and mini Magrav. So if you could just imagine, when I wire this, it'll go from large to small, and then it'll cross over from large to small. That'll give you the, you know, your gradients and everything. And then the second thing is the gradients on the height, so that you know that each unit will be, it'll be in a star configuration, and each pod will actually generate its own star. If for the own, I wouldn't know what any other way to say it, because we're making a plasma field with all the ingredients that we've been taught so far in a small confined unit. And hopefully my hope and wish is that I can get enough of this energy going to at least power the motors to keep the little mini Magravs going. If it makes enough energy to do that, to keep this going, I'll be very happy. And that's my goal. Everybody asks me, well, why are you doing all this? We got this. If I can get to that point, and this unit can do that for itself, that tells me that that's a self-sustaining unit, and it has enough sense in itself for what I've done for it to keep itself going. If it can do that without me plugging it into the wall, I'll be very happy. So that, now I know what my goal was for the end game, and that's what I'd like to do. Once it goes from that point, then the unit actually will be able to be self-sustained. And then I think once you be able to do that, then you'll be able to take from the unit what you need from it. And I think that's the whole purpose. You know, I know we want to go to a soul level, but your soul is, we're all connected, and these are just exercises for us in order to project ourselves to the next level, in order to be able to take us from where we are now to where we'd like to be, or where I think we should have been a long time ago. For some other nefarious reasons, we have not been able to go there, and for this reason or that, it doesn't really matter. I think we should still have fun with these things, And, you know, maybe it's just biding our time for something else to happen. Who knows? But like each week, I just want to tell people, if you frustrate you and get you upset and you don't see results, don't quit, but just, you know, set it aside and, you know, go about your daily life, and you'll be all right. You'll find yourself, you'll go back to it again, and maybe it'll work and maybe it won't work. But, you know, just take a little bit each day. I try to just do a little bit each day. Sometimes it can be overwhelming. Don't let it happen like that, because then you'll just quit. You'll get frustrated and quit. And for some of us, we've been doing a long time and we haven't had a lot of results. But if we still keep our eye on the ball and know what the end game is that we'll all be friends, and we'll have love for one another, and we'll be able to provide for each other without having to worry about somebody else giving us something for nothing. We are able to give ourselves something for nothing. That's our right as humans. And I think if Mr. Keshe keeps telling us, it's our right to try. We have that right, and that's why we're doing these things. And I hope that if it's not me, it's going to be somebody else. And if it's not somebody else, it'll be inspiring for other people to have the right to express themselves. No more of this stuff we got to try a little bit and use our imagination.
Right on, Mark. Yep. Very, very good. Yeah, I know for myself, I've been going through periods of just not getting the results I wanted. I hook up a globe and I rotate it, and it ends up being a more of a water squirter than any other type of experiment going on, and it's mostly exercise in getting the paper towels up and cleaning up another mess. And it's been frustrating at times, but this is the way it goes, and you just try things and see if it vibrates or it doesn't work properly the way you expected, then you try another way. And that's the way it always goes with inventions. It's very seldom that anything is works on the first time around. And if you can visualize really, really well, like Nikola Tesla used to say that he would spend time visualizing how his experiments would run. He would put a motor together and actually run it in his mind for up to months at a time. He would note the wear on the parts as this machine was running in his mind over an extended time period, and he would visualize it actually operating. And he said when he did that and went to actually make the machine in the real world, that it would work flawlessly the first time, every time he did that. So I guess if you can 100% visualize what it is you want, and again, that's part of our forming our intention and forming our a goal, like you were saying, keeping your attention on the goal, and whatever that is, which might be different for different people. But one goal that seems to be prominent is the idea of getting to another level with our stuff, whatever that means to any individual. It's different for everybody, but everyone knows what the difference is between one level and taking things up to a higher level, or taking things up to a deeper understanding, and so on. So I think that's part of what we do is we're working with some principal ideas and trying to wrestle with some new concepts and ideas in our minds that it takes time to formulate this stuff, and envision the fields. And having this ice thing that we just saw, for example, gives us a little better idea, quite a bit better idea, on how the fields might be formed from these apparatus. You know, it's this is a new kind of field to investigate, so to speak. The field of visualizing fields. It's a wide open field, as they say. So anyway, very good, Mark. That's a good inspiration there. It's true. You have to just keep at it and keep reformulating when necessary, and paying attention. Paying attention is so important as part of the process. And through that paying of attention is when that's when the magic really can happen. So it's a matter of time before we do have major breakthroughs, or that we suddenly are working on a starship power plant rather than something in our bedroom or garage or basement or wherever it happens to be that is kind of funky and whirls around, but so far hasn't achieved liftoff, let's say, and may not, but yet it's like a prototype for something, or a model. Let's say this is what we're looking at here. Let's say it's a model of a starship drive, because it embodies all these principles that could very well be in a starship drive. And there's a saying with shamans and those who work with those kind of fields, is a model of the thing is the thing itself. So that in effect, if you can make your model as close as possible to the real thing, let's say, then perhaps it will work as the real thing. And so that's something to consider. And as we refine our designs and work towards something that's more and more effective. But you have a good plan there, Mark, so I hope it works out.
I just think there's people that want to be naysayers, this, that, and the other, but in my heart, I know it's going to work.
Right on. And I know for sure that it will inspire others to think about what they're doing, and maybe if I added a couple of arms on my unit like that, I like those arms, they're really cool. I like the legs you had before too. They were great. I really was inspired by them. I thought, whoa, that is really good.
So as we go on, I would just, please don't ever. It has to be fun. If love comes from fun, we have fun. We love. It's just the feeling is just overwhelming, and nobody can take that from us.
Yes, that's right.
So
speaking of fun, Jay had a question in the chat here, which is relevant. He's wondering if Mark tried to burn a cube, burn the ice cube, burn some ice to see if the coils had produced hydrogen. That's a good question. It's a good question. Maybe we could do a little experiment if you had like a torch or something, and I don't know. You had some bubbles. You had some bubbles on the surface there, some fairly big bubbles, right? And you could, if you had a little, I don't know, even a lighter or maybe one of those mini torches, mini butane torch would be good, or something like that. I don't know.
Jay, you got it. We love to have experiments on the run.
On the fly. That's what we're good at here. There's two main ways of learning. There's and teaching, for that matter. I figure there's two schools of learning and teaching. There's the one school that goes by the book. Everything's by the book, and you follow the instructions, directions, and steps accordingly. And then there's the fly by the seat of the pants method, they call it, which is you go with what's in front of you and you kind of go with the flow of the input of others around you. And in this case, you set up a new experiment just because it was suggested. And Jay says safety glasses. You could have a hydrogen bomb here, you know.
If this experiment goes horribly sideways, we wholeheartedly apologize to the city of Detroit.
Yes. But think of the new source of energy you might have by burning ice. Whoa, look at that thing melted. Wow, that really is effective. That wasn't where some of the bigger bubbles were, but it's you're trying to get down to those, I guess. So we can hear a bit of noise, but like if it's water vapor, it'll sort of fizzle a bit. But if it's hydrogen, it'll tend to either pop or give a little.
Oh. Sorry, Jay.
There was. What about the big ones on the bottom? Wasn't there some big ones on the bottom? I think that's where I remember seeing them. Wrangle that doggy down there. Yeah, there's some bubbles.
Oh, they're crackling. That's just the water dripping.
Mark, you saved
Yes.
it. All the town. All the town is safe now.
Yes, okay, we'll take off the hydrogen bomb alert that we were about to send off and the fake news.
Goodbye, Detroit? No.
Right, okay, well, it's probably air bubbles then, we can pretty much assume that, but it would be nice to get a better diagnosis of that. Maybe it's some other special gases that smell like hydrogen.
I don't know what hydrogen smells like.
It doesn't smell unless it's hydrogen sulfide, in which case it has a rotten egg smell and takes out your sense of smell within about a third of a second or something, like so many milliseconds. It destroys your sense of smell, so you no longer can smell it.
It does have a kind of a funny smell, but it could have been from the butane. I don't know.
Yeah, could be. Well, thank you for showing
Risking
that.
my
That was
life?
interesting. Yes. You didn't even
You
have
know
the
what?
blast shield in front of you.
You know what? I would risk my life because my life is, if I dedicated my life for humanity, for a good development like this, yes, it would be absolutely worth it. I wouldn't, because I know where I'm going. It would just be a matter of, and then when I'm there, and then hey, how did it go, Mark? Whoops! Now I'm here. So, I don't fear death. I'm not morbid about it, but it's going to happen. It happens to all of us. When it comes, and it goes, it goes.
Yeah, it'd be a heck of a martyrdom to show our first definite reactor reaction, but it takes out poor Mark. But we'll call it a reactor Mark 1, and that'll be the first reactor that really worked well. A little too well, but hey, what a way to go. That would be, ultimately, it's the best way to go, to, make your mark in life, so to speak, with your death.
Thank you. That's
You're
what
welcome.
I think. I would put myself out there. When Mr. Keshe says, some of us will make it, some of us won't, but for the good of the cause, if we make it all, we make it all. If we don't, we don't. It's just like the same people that go in the wagon trail and they had to blaze we have to go. We can't stay. We got to keep moving forward. We just cannot be stagnant. We're humans. Don't hold us back. Great things will happen if people don't just get all hung up about the things we're doing. Don't tax me because of it. If it's free, don't yell at me because of it if it doesn't harm anybody. Don't yell at me because it aids people and makes them feel better. Why are you yelling at me when it comes to that? It shouldn't be like that. It should be, go ahead, have fun, enjoy yourself. You're not hurting anybody. And in the meantime, you might help somebody. Why are people so hateful? That's what I don't understand. It's so common sense that it just bums me out that people just are just so mean to one another.
Yep, it's true. And humans have a record of, as far as destroying each other's cultures and whatnot. That's pretty much the history of mankind, is that kind of mentality. But we have an opportunity, I think, now with the energies that are coming on the planet to have a change, and perhaps everyone will be brought up with that change, and we'll literally bring up the next generations with that change built in, so that we have peace and we have progress that helps everyone in mankind rather than just a few. So that's the big hope, at least.
Well, if we all contribute a little bit, which we all are, and some of us are, do a little bit more than others, but we'd be more than glad to share anything we find out with everybody, and that's the beauty of the Keshe Foundation, is Mr. Keshe is willing to help everybody and anybody, and that's the MO of that should be for all of us. It doesn't matter who, how, when, or where. It's all of us together. Everybody in the pool. We don't want to leave anybody behind. Really. I feel sorry for people that I don't want to leave people behind. I really don't. I want to help them as long as I can. Please, let's not leave anybody behind. That to me is something that
there's plenty of room for everybody in this teaching. That's the beauty about it, actually. Is if you want to start with if you have virtually zero knowledge of science or life in general, you can still dive into and use this technology. You can learn the basics, or you can just end up using some product like a health pad and discovering how wonderful it is and turning everybody else onto it. And that's your little job or duty or passion that you find in life, perhaps. And by doing that, it makes you feel good to make other people feel good and be more healthy and so on. So there's room for full scale in this technology. There's room for scientists, and there's room for non-scientists. If you're anything from a musician straight through to rocket scientists can all benefit from this teaching, because it could be that the rocket scientist hears exactly what he needs to hear from someone that's a musician, for example. Like Mario, he's a musician, and he often comes up with these very exact formulations for plasma and so on, because he knows the relationship between octaves and music and notes and chords and so on, and knows how to work with that world. And others have their specialty that they're good at. You might be an artist, you might be a, I don't know, a clothes maker or something, and you end up finding a way to incorporate this technology into your world. And it's not just technology, it's more like a viewpoint. We were talking about viewpoints of what is plasma earlier, and this technology is more of a viewpoint, more of an understanding than an actual, knowledge base of technological wizardry. In fact, you're not seeing all that much wizardry here in terms of high tech, with lots of complicated circuits and interactions and so on. We have spinning motors and we have balls full of GANs and we've got coils and so on. It's very kind of basic stuff, but yet it's all in the details, as Mr. Keshe has talked about recently in both this group and in the Knowledge Seekers workshop. It's all in the details of how the GANs is made, how the nanomaterials are made, whether the coils, nanomaterials and GANs on the coils gets crushed or not by the installation and handling of the materials and whatnot. So all these little things make a huge difference, and ends up in the end that it's a full spectrum teaching. That's, this is what's sort of been ingrained into me over the last few years, is when Mr. Keshe gives a talk, he talks about all levels almost simultaneously, or he'll work in things on a micro level, well, right down to the subatomic level, to atomic, molecular, chemical, nano, GANs, plasma, and then he'll incorporate the whole thing in a bigger picture with the spiritual aspect, the soul or essence thrown into the mix, and that changes everything once again. So it's fun, and here we are staring at a block of ice for the last hour or so. I see it's dripping and melting there. I don't know if how long it's going to last, especially after the torch blasting treatment. Jeez, this poor thing sitting there. But it looks beautiful the way it didn't diminish it at all. In fact, it's got quite an interesting looking structure there, even as it melts down.
Well, I think it's just it's a nice visual aid for us to kind of have a conception of what maybe this might be doing.
Yeah.
It's just another tool, another way, something fun to work with. And that's why out of all this, I still have to thank Lee, because it made me do this, and it actually made me change my design on my other unit, because now I can see what this actually is going to produce is an outbound field that I can collect. That's my thinking, is that this is actually going to be able to, in a rotating manner is going to, I mean the idea of having that moving at any type of speed, I mean that's just at a static state where it's just
That's right. Yeah, well, that's a good point, Mark, and I was thinking about that because, like we were talking about earlier, whether the free plasma would be at the center or the free plasma would be at the outer edge, when we were talking about this model of using circles with the plasma and so on. And in a way, it depends on whether the structure that we have, that circle, and whether that circle is under the effects of normal gravity or whether that circle is being rotated in a sphere, let's say, situation, in which case the gravity changes and gravity becomes everything that's not the center. It pushes outward from the center, and as opposed to normally we get pulled toward the center of the Earth with our so-called gravity that we're under with the Earth and ourselves. But when things spin, they're under that centrifugal force that's like another gravity. And it's much stronger than our normal 1G gravity, because you can get up to 1,000 G's force pretty easily in a rotating structure, which puts all the lightest materials toward the center and changes the way the fields go too, because if you look at least the effect of the fields would be different. I'm not sure if the actual fields change while the structure's rotating, or well, certainly they do. Different fields come and go as the different speeds. So that's known and
Well,
it's part of the whole deal.
You kind of just look at the formation of the ice. If you ask me, the dome of the ice pack there would be just like the top of the Earth, and the bottom of the the ice pack would be the bottom of the Earth. And as it came out and went out, it's making the rings just like the Earth would make the rings. The energy of the spinning of the Earth. This to me is the same representation. Why is it clearer on the left and the right side and real dense in the middle, on the top of the middle of the dome? You know what I'm saying?
Mm-hmm.
Why did it form like that? Could have formed flat if it felt like it. And the curves of it, you know what I'm saying? You can see all the curves, and it's that curvature that's the same way like the neck of a vase or the neck of a bottle that is squished there, like a ring, and that's all the way around it's perfectly around the whole thing like that.
Mm-hmm. And those rings on the bottom are looking a bit like the rings of Saturn as well. You could think of it that way.
Exactly. So it's just a visual. That's all I have.
Well, that was enough for us to go on for quite a while, and I'm surprised it's not melting more. I'm wondering where all the water is going. Must be dripping off the back or something.
Last week it was like that until morning. Well, it is morning now, but when I got up, it was. I mean, it took a long time for it to to lose everything.
Yeah.
I just collected in that pan under there, and I just reused the water again.
Mm-hmm.
So it was the same water. I didn't have to. I maybe added just a little bit, but not much. Just same distilled water. So it's fun. I'm going to use. You got to recycle everything. So the water from here will probably be used in another GANS or whatever. It's already plasma. It's already a plasma. I already have it. It's already got some kind of plasma in the water already. The water's definitely been restructured. So that's it. That's all I got.
Well, guys, because we talk about the Epsom salt, I was done the experiment. I just jump back again to this topic with the Epsom salt. With the nano-coating, I was just drop just small amount, really small amounts of Epsom salt through the nano-coating to the caustic soda and all the stuff, and actually, effect was pretty much well. Field, this part of field was you feel with your hands and stuff like that around the stack, around the coils was much more heavier, much more stronger. And is some small different. I mean, if someone do experiments, I was done few experiments with this nano coating, just small drops Epsom salt, and works really nice. I got some strange device with this nano coating. I show you basically. Just I think be quicker way. Just switch the camera like always. All right, wait a second. Yes, sorry for the shaking. Just try stabilize all these things. All right. Okay, all this stuff is actually nano coated by the sharpness. All right, wait a second. Try find the sharpness. All this strange device is actually nano coated with a strange solution with the Epsom salt. And one thing very interesting happened with the solution. I will start collect lot of guns from the spot. Also, I got inside a piece of in a parcel of gloss because they completely disappear. Piece of zinc, and that's nano coating is actually, I think, is nice. I don't know how well is because my sharpness on the camera is not.
Is this on the ceiling, or are we looking at this upside down?
No, that's okay. That's right. As a strange device, I got problem. Yes, I get the sharpness.
Oh, I see. Yeah, we're upside down, right?
Yeah, I was wondering how he got all those wires and
All
stuff
right,
stuck to his ceiling.
sorry.
Oh,
Sorry,
okay.
that's my fault. Wait a moment, I will try with this camera. Sorry.
Good.
Yeah.
Well, we're
Down.
still upside down. Oh, now we're right side up. There we go.
Sorry about this.
Much better. Now things are making sense. I was wondering how do you get all those wires stuck to the ceiling so well?
I just living in the other part of the world.
It looked okay in Australia.
Yeah, exactly.
Yeah, right. You're on the other side of the planet. That's why. Okay, makes sense. That's the way they do things.
Right. No, that this is long on the same part of the planet. So I don't know how the sharpness, because I have a massive problem with the sharpness on this camera. But
generally, if you can hold the camera as still as possible, then it'll start. Then then it zooms in. There, that's really good. There. Yep.
Okay, I got it. And all this nano coating was made by this strange solution. And the most funny thing, really actually funky, when I actually wash up the coils, just to take out all this unnecessary caustic soda from the coils and just clean up a little bit, just only with the hot water, trying don't touch them and keep all the health and safety regulations and stuff like that. So I was collect something like that. Oops! Always some noise.
That didn't sound too good. I hope it wasn't expensive.
No. It's just a piece of copper. Okay, when I get these guns, yes, that's the guns. And this is when I was collect from the pots. Wait a second, they need to find like always sharpness. Okay, just left me for a second. Come on. All right, I think you got it. And it's really amazing. I don't know what's this. Actually, I know what's this. It's a piece of guns from Epsom salt, of course. A piece of guns from zinc and silver, because it was inside. And actually, that's all. And of course, the plastic bottle cap and the aluminum foil and everything makes some guns like that. It's quite nice. I mean, it's quite strong. I just used them only once time with one stacker, with one Magrav, and looks like a really good idea. This everything is collected from, I don't know, like 2 sets of coils after washing, and that's what stay on the bottom of the container, inside the container. So a lot of ganses in a very strange way, because everything was made by actually nano coating process. And quite interesting thing. I got some idea how to use these guns. I need dry half of these guns. I'm gonna check how they work with Magrav basically, and with the coils. And let's see what's gonna happen. on the strange devices, this is the kind of a little bit different idea. I was saw your reactors rig, and everything rotating, everything is in a move. I was go completely different direction. Everything is a solid state, no any moving parts, and looks a little bit kind of Egyptian style. But it's a very interesting field around, and I mean everyone report the strong field on the top and on the bottom. And it's difficult to describe how they work. I'll try to keep the camera in one place. So what does the device do? And this device expand the field quite enormous way. It's quite big now. It's connected behind the Magrav, and of course I see some reduction of electricity consumption. It's quite not very big, but after just connect this device, after I don't know a few minutes, I was connect the Hoover to this device like 1000 watts and stuff like that, and the 100 watts disappear in a few seconds. Just disappeared from yeah, from energy supply. So this kind of strange things. I was trying just speed up the field this way. I mean, it's still under construction. It is not finished yet. This is the second prototype. This is the first prototype. I was called in the Russian manner the Sputnik. And yes, this is.
Let me get it straight. Is that a copper disc that you have that's with the hole cut out in the middle? Okay.
This is the copper disc, nano-coated. Both nano-coated with the strange solution with the Epsom salt.
Right.
It looks fantastic. I mean, was some kind of difficult.
Cool. It's a cool idea. I like it.
I mean, the work quite interesting. I guess everyone, when they come close to the device, feel a very strong field on the bottom. Very strong field on the bottom, not very strong on the top. It looks like all this energy just traveling across the plates and back to bottom. It's just like a spontaneous, never finishing donut shape traveling across, and with the bigger parts on the bottom and the smaller parts on the top. But it's an idea how to expand the field from the bottom to the top. The idea is very simple. That's the reason why I got the second prototype. Okay, I just need copper plate on the top, and all this field traveling now on the top. I mean, it's very easy to feel this field. You just need to put your hand and spontaneously feel. It's like a fraction of a few seconds, and you feel or warm or cold or something like that. And another part of this field is on the bottom, and if you like to take them down, you just need to put the copper ring on the bottom and connect them with the minus. I mean, the way how you're gonna connect it is always your own decision. For the working devices, as you see, everything is connected to the 220 volts. It's normally fully working machine inside the electric grid. And the field is quite amazing. I mean, one thing is for sure, and you don't need it that much after when you stop this device. Sort of make the quite a big field, and you always feel full with food, with everything. I mean, atmosphere is really good around these strange devices. So this is like an idea for the Magrav, basically. This is how to exchange the typical coils to just normal plates, because actually the field actually traveling across the plates. So if I'm gonna find a way how to use the better way, so it's gonna be more fun. So now this is the experiment. They help me make field bigger, basically. That's all I need for now. And they help all this electric and the electric supply, electric grids to nano-coat in a faster way, I think. sort of things. I mean, and everything is. I just mumble a little bit because it's difficult for me now to describe how many things do these devices and how looks the possibilities for all these things. It's quite difficult. It's quite fresh. So I still do observation for what's actually happened around. And one thing is for sure, and less food, definitely less food. The next things, all the Magrav's work. I don't know. The better is maybe not the best description, but the field is bigger. I was try with this pointer from this energy field, from this electromagnetic field. Check how look the field around. Maybe I'm gonna show you. All right, switch off. I'm not that good with the camera. Okay, maybe now should be all right. Okay, I will try. I don't know, is it visible? All right. Okay, this is funny thing. Nothing, something. And now I'll take the one extension because actually device work parallel with the other device, the Sputnik. 2 Sputniks. Okay, what's happened now? Of course, on the bottom, still same situation, nothing special. But on the top is something. Wow! It's quite a huge field. Okay.
You do that on the top there. Does it go in cycles, like sort of like layers, like almost like Coulomb barriers, like a series of barriers you go through, a series of high intensity and low intensity, like.
Yeah, it's something like that, but mostly on the bottom. If I gonna put, I didn't get now the small copper ring, nano coated on the bottom, and I connect with the mass, with the center rod, I get something like a Coulomb barrier between. I see how all the signal disappears spontaneously in a very precise place, very specific place. This is like a Coulomb barrier, and also I got pretty much similar situation on the top. But if I'm gonna take all the stuff from the bottom and put the one copper ring on the top, everything is connected to the electric supply. I got this sort of situation. I just stretch the field and in an enormous way. It's quite interesting for me because I'm looking for some kind of solution for a medical system. How to build something that's more comfortable, smaller and easy to transport, and definitely basically smaller and much more flexible.
And also directional. It seems like this one is directional. If you can get all the field to go above it and not below it, then you've sort of directed the field that way.
This is the next idea. I just leave it like that for now. But the next idea is made a smaller case. The case will gonna give you this opportunity to hold all this device inside in your hand and basically point it to some area on your body, just like that. Because now I just pointed everything to the roof. But if I gonna put the right stacker.
And what if you had a series of plates that weren't connected, like that top plate? What if there was another plate on top of that and another one on top of that, say? It might act as an amplifier, especially if you made the plates different sizes, maybe small, medium, and large, or something like that.
I was try a few.
That would be very, very interesting if just the nano-coated plate would act as an amplifier for the, the more plates, the more of an amplifier, like a giant capacitor, supercapacitor, actually.
I was trying because I get the nano-coated zinc sheet, this ring, something like that. This is nano-coated. Okay, in a smaller ring, copper ring. All right. No, the field is still giant. Of course, I got plasma lamp in this room, but anyway, it's still.
Yeah, that'll make a difference too.
I mean, that's the difference, because I got a lot of, if you get plasma lamp connected to the Magrav system, you get bigger field. But
yeah.
Anyway, this difference is very visible. Okay, this is normal, but okay, remember, we got the plasma lamp. We need to take stuff out and leave out. Oh, this is Klump. Oops, we started work now. See, this is the Coulomb barrier. I don't know, it's gonna be visible.
Right. Okay, so that's the first one. Now go to the next one up.
All right.
Use your use your same device. Use your same tool. Yeah, and just go up a little higher and see where the next barrier is. Okay, there's one there, right?
At the moment is one, but I worry about one thing. Oops, I know you see or not.
There's another one, right? Yeah. So there's 3 or 4 of them right there in the around
like
that unit.
Yeah, you must be very kind of sensitive and very delicate with this device if you like catch this Coulomb barrier. But yeah, this is very. Yeah, you see this. And the one thing, I mean, the better option is for me use the hands, because when you use your hands, you immediately, this is something like, I don't know, the earth is a little bit different, and you almost spontaneously feel something like a different type of gravitation. Everything is lighter here. Definitely. I mean, it's like
Can you feel different barriers with your hands, or just a lighter feeling above the unit? Like, can you actually feel similar to the electric device there, the sensor? Do you feel the difference in the Coulomb barriers with your hands or not?
Yes. It's very strong, actually. Everyone feels it. I just put this device I just put a few people to this device, basically.
But I mean, when you move your hand closer or further away from the device slowly, do you feel increase and decrease in different barriers, different fields as they come off the unit?
Yeah, pretty much. I think the most funny thing, this 3 copper plates actually much more stronger field. I mean, it's not exactly stronger field. It's stronger by my own sensitivity. I just feel better this type of field. I mean, when you put your hands here, you just feel something like, okay, this is the first one, or something change. You just spontaneously feel all these things like gaps between the different types of fields.
Yeah, exactly.
And the funny thing, because they work parallel, actually, this is like 2 devices, and they connect to the one capacitor to create something like 8 between, like Mobius stripes, infinite loop.
Infinity loop, yeah.
Yeah, and they actually work very well. And seriously, I got this observation when I connect all the electric stuff to this extensions, set up these 2 small devices. It was like a huge saving for energy consumption just by field, because this is only field. It's nothing more. I don't even get time to put the right gases here. I mean, it's only gases on the inside the ball. I mean, yeah. I didn't. I mean, just really light combination gases on probably the first plates. The other completely clean. So I need to actually figure out how to. I'm looking for some good idea for the gases. How to manage all the stuff. This one is already made with the gases. This combination like a Magrav, very typical. It's like a mix between the Magravs and the generator, because this zinc and CO2 middle is a CuO, that's with copper guns, and on the bottom is a CH3. This kind of replica for a generator. so in a solid state. And actually, it's really interesting device. Many people get very solid, very intense feeling when you put your hand between. You feel the fields, how they traveling, how they try, figure it out. And many people.
I really like the design. It has a good aesthetic look to it. The discs, the 3 discs, and the ball in the center just seems right somehow for something to work.
Rick, if that's gonna work, that's a good idea to the medical system, for example, because normally typical system needs stay. I mean, I just looking something much more comfortable. Just sit down and just when you got device like that, just putting this device bottom of your chair, put your helmet, and go. And that's the idea for this device, like a support for all these medical devices with this technology. I'm just looking for something like that. Just make something we're gonna complete. I mean, because in not every situation we need a stacker, we need the full Magrav system. Sometimes we just need drag the fields or just push the field. Not.
Yeah, good point. Maybe you could make it so it's the stick-on model. It goes on your office, underneath your office chair. You stick it on underneath, and maybe even magnetically, magnet holding it on or something, and it transforms your seat into a therapeutic seat which works with you through the day as you work at your seat, at your place where you spend most of your time in your life with people like me. That could very well be a good product.
You know this idea with the box. Mr. Keshe showed this long time ago, this idea with the box when you get all this full medical system with the two walls and the 10 coils on the one side, 10 on another side, the helmet and stuff like that. And that's actually part of how to minimalize the system, because as you see, I got these columns and the helmet. This is the second system. The first one is already working condition. It's outside of London and it's actually very successful. And everything is fine, they work, people use them, it's nice. So, but the different helmet, this helmet stay here, and this helmet finally will be connected to all these columns. So the idea for the small devices is actually replace the Magrav inside the box. When you get the box, this big idea for this medical system to actually to take all this field down and create something like a spin inside the box. So that's the kind of temporary idea how I gonna make the spin physically by Magrav on the middle. I think using something like that. So, but let's see the experiment thing. I mean, it's quite interesting to do something like a lamp of on this big Jeep car, something like that. I forgot the English name. English is not my native. Anyway, it's like a big lamp, something like that. When you're gonna hold it and you're gonna point it to
like a headlamp, you mean? Is that the word?
Like this, yeah, something like that, yeah. Something was gonna be easy to manage, and if you got some problem with some specific part of it gonna be really good idea. Use this device like a kind of Röntgen system. So let's see how they're gonna work. Now is a prototype. There's still things to do. I need to figure out with the capacitors to the system and how to connect each other. And so let's see what's gonna happen. Now looks fantastic. Everyone love it because people feel these fields. I don't need to ask about anything. They just nicely come and say, "Oh, Tom, I feel I feel this. I feel hot. I feel cold." Something like that. So
right, that's a really good point. I mean, you can explain till you're blue in the face, and you've got all these fancy formulas and descriptions and so on, but it'll just go right through people's brain. Whereas if they feel something, then they remember it very easily, and you don't have to explain anything. It's feeling the fields. In fact, we thought maybe we should have some T-shirts just feel the fields. It's not
Sounds
so
good.
bad.
I was one evening when because sometimes I think, because I spend a lot of time with these devices anyway, sometimes I feel I see a little bit more than normally, and sometimes I see some like small sparks, like this is not like a spark, it's like a light, something like that. It's not like a orbs, it's like a small sparks traveling across the devices, something like that. And my experience with this, I was a lot of was with the small one, because this one was unexisting this time, the first one, and all the sparks traveling across the plates to the middle, just like that, to the middle. But this is only part of the movement, because they create something like a bigger flop on the top, and they're traveling to the bottom. It's like a basically donut shape, and it's so strong. So, and yeah, and between these plates, sometimes they look like a spark gap, like a plasma spark gap. Basically, it's like an equalizer or something like that. Sometimes, I mean, it's not what's happened always to me. It's sometimes just few situation, few moments, I just see something, and that was like a kind of spark gap, classic spark gap, plasma spark gap.
Yeah.
And I think that's the reason why they expand the field, because narrow edges for all displays, they actually expand the field. And this one is different one, because this is only ball, as you see. Do some close look up. As you see, this is only the ball inside. Feels I mean, the plates are connected by small piece of copper on the other side. And this one is a different construction. This one is connect, I think, in full scale, because this is the copper rings, just cut it to the right size. This is the one copper ring, this is the second copper ring, and between you get the plates. And on the middle, you get the, and on the middle is the ball. But ball is not typical, because it's not fully like a full ball. Is, as you see, is with the shaft inside. Empty shaft. It's the same like actually the same like a reactor, because that's why I tried recreate this like a solid state idea for all these rotating bulbs. I saw it, for example, in your hands.
Yep.
It's great. This is like a Caroline core. Sorry, this is like a Caroline core inside, something like that.
Yeah, it's interesting. Yeah, I've got something I could show here that's sort of related to that. It's more on a solid state. Let's have a look here.
I mean, the one thing is really fascinating, that how strong is this field. I was trying with the spinning reactors on the small electric coolers and stuff like that, with the small glassy balls and stuff. And I just try to speed up with it. Maximum was like 8,000 RPMs, and was field was everything, was sound, was the most funny thing. But it's not the same. It's not like solid state device. I will just try
it's true.
all
it's
idea
true.
to the solid state. And the one thing was happened. I mean, basically everyone report to me that the field from the solid state device is X time bigger than for all these rotating reactors. When I got these reactors, everyone just come and watch. Okay, reactor, yeah, they rotate. Oh, yeah, that's cool, that's funky. It looks funky. Oh, what is it? And that was all story. With these devices, I don't need to do anything. The people just put the hands. I just only need to say, okay, please don't touch, because it's a 230 volts. Everything is 200 degrees. But please don't touch. Be carefully. And the people, okay, and they spontaneously put hands top of the devices, and they got this big smile on the face. Like, wow, I feel it.
Oh yeah.
Yeah, of course you feel it. That field, there's amplification for your own field, actually, always. That's why I think behave like this is only like a I just only push your own field when you stay close to this device, because that's your own field. That's what you feel, I think. But this is, you know, through the further research, I need to check a few ideas with this.
Yeah. So what I've been playing with is the idea of trying to create fields, like you're saying, without having any rotating parts. So I was playing around with this coil that Guy actually made last year. It's a special winding, and go ahead.
Rodin coil.
It's similar to it's more or less a Rodin coil. It's been distorted a little bit. I've bent it into more or less a cup shape here, and some of its strands are a little marginal. But I made it so it fits this this orb here, and I was experimenting with different ganzas in here, trying to get some rotation to happen. The way it's set up is I've got it wired up here directly to this amplifier. This is a car amplifier, and it's got 12 volts going into it. This is the speaker connection here, and this is the input here. And the input actually comes from my computer sound, and so I couldn't really get much in the way of movement with the ganzas and different materials I was putting in there. So then I thought, well, what I'll do is I'll try putting a magnet in. So I got this neodymium sphere magnet, and I put that in there, and that's when I could see some manifestation of movement. So let me just try it. I've got a frequency tone generator here, and I'm not sure if the lighting is proper. That might be a bit better. And let me see if I lower this down a little bit, might help to actually see in there. Just bear with me for a second here. Lower things. There we go. Oops, not that low. Okay, we can sort of see there. Maybe I can put a piece of paper in behind as a way to see the action easier. There we go. There you can see the ball there anyway, sort of, in between the coils. Now I'll turn on the frequency generator. Let me see here. Is this going to work? I think it'll work alright. Oh yeah, you can hear that. Okay, yeah, hopefully it won't be too loud. I don't think it'll come through loud. If I turn up, I can show you how the frequency generator works in terms of I can select different frequencies, as you can hear there. And I'll be selecting, I'll be turning up the volume, but going down in frequency. And I actually have to plug in this unit here first, so just...
I don't know, maybe you should use the brown noise two frequencies, two invisible frequencies to create the visible frequency. Sort of.
Well, that's possible to do, I guess, but let me see. Is this going to work if I do this? That's the thing about it. Let me try it and put that in there. You may not be able to hear any actual sound out of it. Hopefully that's the case here, actually. I think that's working now. Okay, let me... this is all pretty funky. think this is proper. Let's see here. Oh yeah, it's starting to rattle. That's a good sign.
Wow.
Okay, that's at 48 hertz there now, 48 cycles per second. And you can see it's making the little ball vibrate a bit. Let's reduce the frequency. 47, 6, and so on. We get a little more bouncing action happening in there. We're at 40, 37, 36. All right, all of a sudden we've got rotation in there. That's at 36 RPM. Let me lower it a bit and see what happens. 33. Seems to stay about the same speed. Starting to slow down a bit there now. I'll take it back up again. So it's at 25 hertz there now. 28, 29, 30. It's getting a little confused. 33. It's actually at 35. Let's just keep increasing and see if we can keep going with it. We're at 39.
Have you tried this with just a plain ball bearing, Rick?
Starting to create a bit of a vortex inside. Well, it falls apart at 42. I'm going to go back down again. Back to 39. Let's see how low I can go with it.
It's like a Nikola Tesla egg.
At 25. Still going around. Okay, it's not too happy at 21. It's bouncing around like crazy. 19. As we get down into like 11, 10, 9, 8, 5, 4. This definitely has less influence. I thought it was going to bounce around a little more, but it didn't.
Well, that could be a function of the lower limit of the amplifier as well.
So back up again. It's at 19, 20. Okay, at 21 we're starting to get this circular motion again. Try a little higher. You see how the fields are still working, still influencing it up to about here. Starts. I can feel it vibrating the ball there now. Oops.
Wow.
I hit the button. Anyway, that is basically it. Just wanted to show how that worked, and take it back up a bit here. sometimes I've had it going a lot, a bit faster actually. Oh, it's starting to create the vortex there now. It takes a while, I guess. But you can get it spinning at a certain speed. It actually creates the vortex inside. Now you see things spinning around in there. So definitely we have a rotating field going on with this frequency put into it.
Definitely, yeah.
Okay, I'm going to stop this now so that we can talk without it doing that. So the idea is that once you have a rotating field, then we should be able to create some sort of effect in there with at least
Okay,
you know, it's a magnetic effect. But I thought maybe the iron GANs would be able to rotate in this field, but I couldn't get it to do so at least with the frequency that I used. Now it may be possible with the combination of frequencies or cross frequencies, which I can do with the apparatus. I'll just show you briefly the screen I have.
I've got probably similar experiment now.
Oh, I'm sorry, I'm not hearing you because I had my other...
All right.
Sorry, I wasn't hearing because I had my other plugged into my...
No, I was only, yeah. I was happy to see once again Nikola Tesla in action. It's like a Nikola Tesla egg.
Yeah, it's true. Yeah, you could do the egg with this frequency generator probably. That's what it looks like on the software.
I will show one more because you say about this motion. Because yes, I do experiment with this motion. Okay, camera is visible. Yeah. Okay.
Yeah, just a second while I get you lined up here.
All right.
Have you tried that same experiment with just a plain ball bearing, Rick, rather than a magnet with polarity?
No, I haven't. That's a good idea, though, John. I can try that actually right now, basically. But let's go with Tom's thing here first.
Okay, as you see this ring, this is like a copper ring. Okay, I show all the construction because on the bottom I get collection of gases and there's like a small star formation, and that's Magravs, my friends. But they do some extra field here. So that's the gases. Very basic. I mean, it's not even star formation. It's something that imitates star formation. Basically, 3 coils, and the 4th coil is here. It's completely unconnected. It's a wireless system, and on the nylon strip, I get something like that. This is the copper ring, but it's not only one. It's like 2 copper rings. The other is on the end and is with the dot on the middle, which is normal plate is a capacitor. With the dot on the middle is a reactor, basically. Is a battery, because this is the place when plasma is forming. So I get connection like a capacitor and a battery capacitor. And the most funny thing, they never stop. They're always. I mean, apart, I move, across apartment and there's some wind and other things. But even if you're just sitting in the other corner and you're watching, the ring comes non-stop traveling. To left, to right, sometimes faster, sometimes slower. I don't know, we're gonna see the movement. And this coil on the bottom too. And they just rotate. This is like, and this spin comes from the gases on the bottom, I think. I mean, it's basically field. I mean, it's difficult to describe when directly is made, actually, this field. There's a few devices in this room, but you see the kind of rotation movement non-stop, and they never like to stop, never. They just from left to right, from left to right, from right to left. See, this is something like that. It's really hypnotizing picture when you watch this, because looks sweet when you're sitting in other part of the room, and it's not your breathing,
Your audio broke up there. Yeah. One could say convection currents and wind currents and so on, but maybe there's plasma currents.
This is definitely plasma currents. We try put the stronger with the friends with stronger few magravs in the bottom, and they started to move faster. So this is the kind of movement from the plasma fields. When I got here, it was quite interesting. I just feel like a small kid who just watched something. Pretty boring for everyone. It's just only piece of copper, but they spinning.
Yeah. Right on.
Watching copper.
Yeah, watching copper spin. Do you watch your grass grow on your lawn too?
Yeah, watching copper. The next episode, second series.
Okay, let me go back to my little experiment here that John suggested.
So thank you for this for showing me this quite amazing ball.
Yeah, thank you.
I was just thinking, Rick, with the magnet, the spherical magnet, you've got a polarity on that magnet.
Yeah.
So unless that polarity lines up consistently with your generated fields, it's going to be a chaotic movement. If you just use a plain ball bearing that's not polarized, it should actually track those generated fields.
Here's the test. This is a plain ball in there now. Get my generator generating here. See, we're back at the same 31 hertz frequency. I'll have to bring you folks at home back over to the experimental device here. And I think we're ready to go. Let's give it a shot. Oh, no. I gotta hook up my audio, so I won't be able to hear you briefly here while I do this part of the experiment. So if I rant and rave and I'm not listening to you, that's why. Okay, we're hooked up the other way around now. Okay, I don't see much action there yet. Let's see. Okay, our volumes are up. I'll try to lower the frequency. It's usually the lower frequencies will give more of a response. Hello. Keep going down. At 12. Oh, we have a little jitter at 9. I don't know if you can see it. It's just a very little. Let's see if I can get it to start. Encourage it a little. Come on. Maybe like counterclockwise better. Go, ball, go. No. Let's, okay, I'll lower it a bit more. Down to 9, there's 8, 7, 6, 5, 4, 2. Yeah, it's not behaving. It might need more amplitude to be able to. I'm maxed out now with my volume on this thing. Trying to go back up again, and it's just not responding. Okay, well that's interesting. I did try it with 2 balls, like to throw another actual magnetic ball in. That gets them jumping. All of a sudden we've got Instead of jumping beans, we've got jumping balls. If I lower the frequency, they get quite active. Until finally it's down to 2 hertz. And then 1. One's pretty mellow. And if we go back up again, that's 2, 3, 4, 5, so on up to 7, 8, 9, 10, 11, 12. I've seen it go and bounce off at the top of this unit here and go right up and hit that white top. It's actually amazingly fast motion inside when you consider trying to move a ball through water. It takes a lot of energy. Let's go up higher and see what happens as I keep going higher. 20 hertz, 25, 30, 35, 40, 45, and so on as we get up to, say, 60 hertz. Oops, I went the wrong way. Up to 60, which is right there. And as it goes even higher, it just becomes less and less of a vibration. Etc. There's 440. It just sits there and vibrates. And as you get into the really high frequencies, there's 1760 and 3520. There's virtually no movement of the ball. Okay. So, put that in your data for those that might like to play with Rodin coils and I just use an audio program or it's actually a frequency generator rather, but it's for notes, for audio notes, and that was adequate to create the fields inside this device here. And it actually creates audio sometimes too. You can actually hear the fields. I don't know if you can.
Yeah, I think it was 1760. We heard it whistle.
Yes. Yeah, that's right. If it's in the higher realms, that's right. Anything above about 1,000 or so, you start to be able to hear it through the system, which is interesting because there's no speaker attached at that point. It's just right through the vibration of the wires themselves. I noticed that at certain frequencies, maybe I can do it here. It's kind of interesting as a side note. At a low frequency, I think it was around 8, and oops, I have to turn it the other way around. Yes. This plug in.
I get the idea now to put the
Okay, so
the speakers.
I hold this up. Maybe it's actually lower than that. I'm not sure why it's not doing it now. Maybe it has to be the larger ball. But the point was that I noticed at one point the actual wires were bending in. When I raised this up a bit, the wires would bend in with the pulsing of the coil. Maybe it was with the square, might have been the square frequency. Let me try that. Yeah, you can see a bit of movement there. It's subtle, but when the ball comes actually close to the coils on a particular side, the coils will bend in with the forces involved. Alright, well, didn't mean to get too heavily into the matter level electromagnetics, but it might be relevant to somebody out there at some point in time. You never know.
You know, the frequency is only proportion between time and space. That's actually the most simple explanation.
That's really weird.
If we got frequency.
This thing's making noise, but my frequency generator's turned off, so. I think it was residual in there. I'm just going to turn that back on again briefly. Alright, so it's turn it off. Nada. Alright, well, some anomaly, as we call it. A ghost in the machine. Alright, anybody else have anything to present? We're at the close to 4-hour mark here. Starting to fade in the brain. But,
may I ask a question?
What the hell is doing it again? It was going whoop, like it was moving back and forth.
May I ask a question,
Well,
Rick?
it's doing it again.
I don't think he has his headphones plugged in right now.
What the heck? Oh, maybe there's some, maybe it's just when somebody talks or there's some audio coming through on the speaker. Someone tried talking. Yeah, that worked. Okay, that's what's happening. Probably you're trying to contact me. Maybe I should plug in my other wire. Okay, that's what was happening. I was actually hearing... Well, that's kind of a weird thing. I was able to hear your voice through this machine in a way. I didn't hear a voice, I just heard a vibration. I couldn't figure out, why is this thing vibrating? I don't have my tone generator on. But it was actually somebody's was talking on the audio. Right, and it made this jitter, and I couldn't figure out how is this thing jittering, because I couldn't hear your audio with the wires the way they're hooked up, you see. So that was an oddity.
It's just the forces. It's just the forces between the copper wire, and I think it's some iron ball you have in there, right?
Yes.
Yeah, that's quite normal. Same principle as in the speaker.
That's right.
I have a question, if I may interrupt with that.
Mm-hmm.
I'm considering making some reactor balls, and I have a lathe, so I have worked with metal all my life, so I guess I would like some, but what material is preferable? I don't have access to copper unless I use a lot of money for getting copper rods to make the balls.
That's right. That's what Armin ran into. Armin is an expert on that as far as that goes. I don't know if he's still in the chat here, but he knows.
My question is about the material. Can we use brass?
Okay, what do you wish to accomplish with your reactor?
What I would like to do is this simple setup with one directional lift, two balls towards each other.
Two core reactors, is that what you mean, like?
There are two core reactors and put them up in an arrangement and try to make a lift condition in that.
A lift condition, okay. So you'll have maybe counter-rotating reactors, or they could be on the same rotation, whichever. And but separately controlled. You mean two separate motors to control the rotation?
Yes, I have motors and I have electronics. I have
basically
everything I need to do it, but I will.
What would you put inside? What would where? How are you going to create your free plasma inside? What kind of materials are you using? Gases or ganses or solids or nothing? Or what would you put inside the reactors?
We had a teaching where there was used some ganses and some GANS water, I think, and it was nano-coated inside and outside the reactor.
Okay, well that's it. That is the point that I was going to get to, is what kind of nano coating, if required, would you need in your reactors according to how it's loaded and so on. If you were using gases, for example, in the way Mr. Keshe did in his original reactors, as seen in the patents and seen in some of the earlier pictures and whatnot, then it would be a certain type of nano coating you'd want on the insides. The idea being, the principal rule of those reactors being to not allow the plasma that gets created to contact the walls of the reactor, because the plasma will be dissipated by the interaction with the walls of the reactor. So various, you can use a gas, for example, to be that barrier between the wall of the reactor and the central core where your ionization process, where your plasma's going on and so on. So that's the idea with the multiple gases. You can have multiple layers to transition the energy and to absorb it in different ways and protect the walls of the reactor and so on. Or with other materials, then you have other situations. Some reactors don't require the nano coating. With some of the GANs and plasma water and so on, we've seen it was the plastic reactors, for example. But if you're probably going to be using metal, it seems like, and
I have bought 10 40 millimeter plastic balls, transparent. I plan to use them first to see what happens inside, because the metal thing, I cannot see anything.
Yes, that's the big problem with the metal, unless you have a micro camera that can be installed at the same time and rotate with the unit. Or a viewport window as well can be incorporated. That's what Keshe had in some of his reactors. And I've noted with a rotating sphere, if you have a small viewport in a sphere, when it rotates, it looks like you can see right through the viewport all the time, because there's a sense of vision with more than 30 times per second.
I know the effect. That's a way to do it. But then you have the sealing problems and all that.
Yes, big time imbalance and everything else. So again, you have to look at exactly what materials are going inside, what kind of nano coating you'll require, or if you require nano coating, and that will help determine what materials, like for example, at one point we were all building stainless steel reactors, or thinking in those terms, and everywhere I went I was looking at stainless bowls, like, oh, is that going to be the right shape? No, I don't want that bowl. I'll try this bowl. No, maybe not. Maybe, I'm thinking, how am I going to get these bowls to bolt together and seal, and all these engineering problems. Well, Mr. Keshe noted in one of our workshops that stainless steel is one of the worst materials for a reactor. I'm thinking, how could this be? You know, and we've been trying to do these stainless reactors, but it's one of the worst materials because you can't nano-coat it, and you know, besides that, it has magnetic properties you may not wish for, and so on. So it turns out copper is probably the best material for most of our reactors, although that gets iffy in building as well. Like Armin was saying that he used 100%, I think it's called oxygen-free copper. So that makes it quite expensive, and you have to start with a big block. If you're going to end up with a reactor this big, then you need an actual block of copper, or you know, a dowel or something. But usually it would come in a block, and it would have to be machined out, and you have lots of copper shavings left to hopefully use in some other experiment. And it's expensive that way. That's the old way of doing things, and it's called subtractive manufacturing, or subtractive. It's, you know, that's what machining is. It's a subtractive process. Whereas now most things that are being built is done with the additive process through 3D printing and 3D where you start with a bare plate and you only add the substance that you want to make your thing out of. You don't have any waste that way. There's no chips and you know, curls and stuff.
I have been 3D printing for 2 years. I think I have printed 5,000 hours or so with two machines.
Wow, yeah. Well, they do have 3D printing of metals now, of course, as well. So you can print in copper, stainless, you know, titanium, whatever.
That's in another league regarding money.
Well, you can have a company do it, and again, it's still expensive. That's the thing about it.
But I do, you know, if I go to a metal scrapyard, it's amazing what gets thrown out. If I find a piece of metal that contains the thing I want to make, I have the machine to do it.
Right. Well, if that's, you know, if machining and doing lathe work is your specialty, then that's a good way to go, because you know what you can do with what you have, and you know, you can change things easily. If you need to drill something or tap something or whatever, you've got the setup to be able to do that. And you know, I've recently got into the same thing here with, because I have a lathe set up now that I work with, and so I've got my little setup there, and I was playing with it. That's what's been so frustrating recently, because oh geez, to do the dance here. I've got like normally my safety shield's on the other side, so I've got the sphere set up here, so I can rotate that, and I've got a fitting that I glued onto the sphere, and so I've got the shaft goes through the fitting, so I can rotate this the doodad inside here. I should get it a little bit closer. Let me just do my closeness.
Is it to make it run to make it centered? You do that, or why do you put that pin into it?
Because I want to do a counter rotation thing where this is actually this is a sort of a cage, a gold cage in the middle of this thing here. And see, I can move it in and out while there's water in there, and it's not leaking right now, but it will a bit when it's spinning. And that way I can rotate this in one direction. I can rotate my apparatus here in the other direction. It's got a little bit of a shake, so I need to reset it now. And what I did is I actually set this shaft up with my little new little motor arrangement here, and it's pretty basic. I can sort of show the way that works. Let's get this
But what would you recommend that I make 2 reactor cores separately, or I have them concentric?
Eric, do you have access to a lathe?
I have lathe and milling machine. You know, I'm retired now, but I have worked with CNC machines, and I'm an engineer. I have worked with science mechanics and electronics and all kind of stuff during
Okay.
more than 30 years. So it's no problem for me to create the things, but you know, for me, I'm completely new here. I don't know much about gases and all the special properties and how you should match them and all the things. You know.
Okay, well, I'm a tool and die maker by trade, so we're basically in the same field. For cost effectiveness, for making the copper reactors, I would suggest metal spinning. Take a sheet of copper and actually put it on your lathe and spin your spheres. Spin your
Just
house.
like you make, just like the same way you make lamps and so out of plate.
Exactly, and with your lathe and a spherical attachment on your lathe, you can create a spherical form that you can metal spin your copper around, and that way you have a nice thin wall. Make it any size you want.
It's a good
And it would,
suggestion, and that would be the most cost-effective. Certainly, way more cost-effective than trying to machine it out of a solid piece, which Armin has done, and it's very expensive. It takes a lot of time, energy, and materials, especially, to do that.
yeah, metal spinning, it's a bit of an art, but it is quite possible to get a nicely balanced, well-running sphere out of doing it that way.
Yeah, it might require to anneal the copper once or twice to reheat it to allow for the work hardening of the stretching of the metal, but
Yeah.
it probably would go right into a half sphere in one shot without having to reheat it, I would think. I don't know.
In order to do that, you also need, what what about joining things together? Because if you make a sphere and you want, I would like to have a kind of tube to the axle. So I have a motor with an axle, and then I can replace the spheres or the reactor cores. You know,
Yeah, well,
with an axle and
if you're spinning hemispheres, leave a flange on the hemisphere. I think Rick just fell over.
Just
so
the camera.
You'd make 2 hemispheres, and then while they're still on the form, drill your center hole for your bearing system and your seals. It doesn't seem that complicated to me. I'd love to do it, but I don't have access to a lathe.
what about if you solder something together with a copper solder?
No, it's been said many, many, many times on all of these reactors, no solder. Use mechanical connectors, mechanical connections.
Okay. What's the reason? The different material or
yes, I think
mechanical strength, what?
Well, I think it's the different materials. I know when we're dealing with our standard Magrav reactors, if you solder a connection, you're actually going to block the plasma flow. Your plasma is not going to pass through that connection. So we need a mechanical with that.
How do you nanocoat the solder connection is the problem. Like if you use silver solder or even a regular lead type solder, even silver solder will have some lead in it probably. It'll have those 2 materials that'll be a different, like the seam will have those other materials, and if you're plasma inside of a ball like that, then the thing you'll go to is anything that looks like matter level. And if all the thing isn't all nano-coated uniformly, then that plasma will just get absorbed and dissipated immediately in those places that are not the same.
Yeah, and with 2 pieces.
But you
With
can
two nano-
get solder that it has copper and some kind of brass solder material. You solder at 700 degrees or 800 degrees,
You know
and
what?
there's copper.
When Mr. Keshe showed the reactor, this was probably 2 years ago or 2.5 years ago. This was on the start when it was the big flotation reactors and stuff like that. And it was problem with them. I remember was maybe 8, maybe 9 teachings. One of the first teachings with these big reactors, and was issue with how cover up these reactors. And the guys figured out to use the silicon glue, because was no any opportunity to soldering, because the composition of this both metals, even the more metals inside the soldering material, create different fields. And basically we actually, was unable to control these fields and stuff like that. Was difficult to what's Rick said, to nanocoat and all the stories, how to actually the material. So the idea was how to basically avoid all these unnecessary things, how basically shave everything from this unnecessary connection. If it's something to glue, the job to do is to find the best glue, the glue who is who didn't work like a kind of blockade to the signal, because signal come from outside to the center of the reactor, and they jump outside from center of the reactor to outside. It's like a two movement to the inside and outside. So, and if you're gonna lock this reactor with some strange materials, all the plasma fields from inside is actually like filtered by this extra material. So outside the reactor you get nothing basically, because everything disappears inside this strange composition. I'm not an expert with these reactors, because that's my friends in Poland. Sometimes they built one and they get massive problem with these reactors. Exactly how to figure out with all this soldering story.
Yeah, I just asked to get an idea why. Different materials. That's of course.
Let's back to field. Let's back to field. Because what we're looking for a field. It's not necessarily piece of metal who actually rotate with 50,000 RPMs or whatever. We don't necessarily look for something mechanical. We actually look for field, and if you know how to figure out with this field, maybe there's gonna be small movement, maybe even no any movements, maybe finally gonna be solid state engine without no any mechanical parts. So the story is how to work with the gases, and don't do too much with the mechanical elements, I think. But this is only my approach. Of course, is a lot of funky thing with all this mechanical stuff. I do also sometimes do this kind of things, but the case is the field. And if you're gonna figure out how to create this field, maybe that's gonna be, I don't know, the small ball in your hand. We have no any moving parts, moving elements, and this ball gonna be fitted by right collection of gases. And as we are like a species gonna be ready to manage this field by itself, and that's gonna be only small ball in your hand, and you're gonna travel across the space using this small ball, because the only one thing what you need to do is build the connection. Me too. To build the connection between that's what we named gravitation and us self in a different way, not like very deterministic like now when we actually walking top of the earth, but in a different way when we started flying. When we started, really good, fantastic senses on the start today with the gravitation.
So you're actually saying that that we don't need all this mechanical stuff if we make the composition.
Not necessarily. I think this is a very individual story, because this is the level of understanding by every single us. I mean, if you need build some mechanical element to catch something, do it. If I will need build something mechanical, I'm never gonna stop myself. I gonna do it. Maybe I gonna bring some extra knowledge to to how to skip basically all these elements. It's not like something is wrong, if something is better. It's nothing like that. It's just the way how we personally go to this discovery. I mean,
Yeah, it's different perspectives,
Yeah.
and like we spoke about earlier with the different levels where you can look at things either as GANs or as a nano or as a plasma or as the matter level and so on. So it is with these reactors, and we all have different understandings of. We tend to, by habit, hang out in one of those realms, basically. We tend to think about nano more than anything else, or we tend to think of GANs more than the nano or the matter level, or we think about the matter level stuff, or we think about the plasma level. All these different aspects or ways that we can think, and if we're able to jump around and look at things from all those different angles, I think that gives us an advantage over someone that might get stuck in one particular level maybe their entire life, and they think all there is it's all about the nanomaterials. It's over a $10 billion industry yearly now for nanomaterials, and it's supposed to become hundreds of millions into the trillions of dollars a year industry shortly. But that doesn't mean that we have to just focus on nanomaterials. We have the GANs, which is a whole other world in itself, and then if we want to go and see things just as plasma and just do pure plasma experiments and so on, we could take it even further. For me, I get stuck doing various experiments, and they seem to get more and more complicated as things went on and so on. And recently, I wanted to get back more to basics. So I'm thinking, well, basics is a rotating globe of water or some other liquid, and what can I do with a rotating globe of water that is very basic and simple, but doesn't require the interaction of a lot of rotating parts and so on. And that's why I was trying to get more into this sort of thing with the using created fields to be the source of the rotation. Or even in this device over here, which is actually, even though it seems like it's set up for, this is the lathe thing, even though it seems like it's set up for rotating and so on, it's actually, I have it rotating only so I can do the main experiment, which is a sonoluminescent experiment using a speaker basically, and causing an implosion bubble in the middle of this sphere, where that way you don't need to even necessarily rotate it, although I believe it's easier to create with rotation. You're just using sound to create an implosion bubble, which creates light. So you're creating light with sound, essentially. So I think that's as basic as I can get, and I like that track. So I'm going to continue playing with that and investigating that.
I've heard about that before, and there was a guy who said that he had success doing this, but what he did, he was if you think of light and concentrating light, then he had some ultrasound emitters and a mirror that focused all the sound in one point, a parabola, just like in the headlight of an old car. Yeah. Yeah. Yes, that was the first part of the scaping, and then they grinded it and with this special diamond mechanism to make the super surface. And I can tell you another thing about the parabola. I don't know if you know the company. There was a Danish company, not so big anymore than it was. I worked there. There was over 500 engineers, and they made a device to measure very, very small concentration of gases. And they did this in a very special way. They had an infrared source and a parabola, just like the headlight on a car. And then they put gas into that chamber, into the parabola, and they had a tooth wheel that cut the emission from the infrared source to this chamber. And by using filters, selecting the specific wavelengths that a gas absorbs and focusing that in the middle of this parabola, they measured with sound that the air, or the gas expanded with a frequency from the tooth wheel, and they could use that to measure very, very accurately. That parabola was very, very precisely made, and it was also with gold inside, so that the surface would not corrode or lose quality in mirroring.
Well, that's a good point, and I thought with my little thought experiment with rotating a globe like this and creating a parabola lately, that if it had something that sat on the surface, like powdered gold, for example, of a certain size, won't sink in water. It stays on the surface. And if that powdered gold was on that surface while this was rotating and formed the parabola, you would have a perfect focusing mirror.
Yeah.
That's adjustable with RPM. Finely adjustable, I might add, with exact RPM with a servo motor, for example.
But I don't think it's that complicated, because if you want to make sonoluminescence, then I don't think you need that accurate. You could use a lathe to make it and polish it in some material, because this is not about optics. This is about sound waves, and the wave is much longer. So you don't need this high accuracy in order to focus the sound waves. And the guy
that was a different application.
He used it to generate energy, because he said when you hit the right frequency, the water is very easy to separate when you focus and you make the sonoluminescence.
That's right. Yeah. Yep. So ultrasonics is the way. Every vessel has a resonant frequency depending on the volume. So, for example, a liter of water has a certain resonant frequency. I forget what it is. I think it's around 12,000 hertz or something like that.
I think they use around 40 kilohertz. Something.
40 kilohertz is the standard frequency for what they call a transducer, ultrasonic transducer. You can get them down into the 20,000.
The water also has a resonant frequency
around
that range.
That's the thing. You either have to make the bottle be about the same resonant frequency as that, which is probably maybe a 100 milliliter or smaller vessel, and that way it's within the range, because most of those transducers when they're set up, they don't like to run outside of their range too well. They have a little bit of
No,
variance.
they have no efficiency
That's
outside
right.
the resonant frequency.
Yes, that's right. But you can, what I actually did, let me show you my boo-boo of the week. I'll be right back. Now that you bring this up, I might as well embarrass myself.
There's no reason.
Sorry, I couldn't hear. I had my headphones off. Go ahead again.
The ones that don't embarrass themselves, they get nothing made. If you're afraid of doing something,
You can't be afraid of failure and even expressing
no.
it. So what I did was, I'm thinking, you know, ultrasonic transducers and so on, but the trouble with transducers are exactly what you're saying. They usually have a specific frequency and they've got a whole mechanism that goes with them and so on. So I figure why not just go with, let me reduce my video here. Why not just go with a speaker, a tweeter? Because tweeter speakers, you know, they're high end. They'll take basically up into the ultrasonic range. And sure enough, I found this heavy duty aluminum marine tweeter. This is like the most powerful baby you can get. 350 watts of tweeter. Beautiful little unit. Right?
Yeah.
Yeah. Really slick.
Guys, you tried one thing because
go ahead.
It's quite interesting thing if you're gonna make the capacitor, the plasma capacitor, normal or whatever you like, your favorite plasma capacitor, and connect between the speakers and the amplitude.
Well, that probably would have been a good idea because it turns out that these speakers do have a capacitor that actually comes with them that apparently you're supposed to put in to keep the low end from blowing them. It's part of the transfer mechanism. But what happened was I did not use that unit and I hooked it up actually probably backwards now that I see the little insignia that they kind of hid on me. And I promptly blew it out within 5 minutes, so my experiment didn't go very far. But I had a
it's just like a just extra like an extra capacitor on the cable between your speaker and the amp.
Yeah, it's probably a good idea. The way I had this set up, I was going to put this heavy-duty tweeter speaker inside of this. Okay, so you can see it there now. And then I can take my, well, any of the spheres that I have, but specifically this one. And I put some weather stripping around here. And the whole unit still does, presses in there and makes a really kind of a cool little setup here. So it's got the ultrasonic speaker. And what I'd hope to do would be create the sonoluminescent bubble in the center here, and I have a septaseal that I can access so I can actually access with a hypodermic through the center down into the sphere, and I can place a bubble at the center of this sphere while the ultrasonic is happening. And it doesn't have to be an air bubble. It could be a hydrogen bubble, for example.
But according to what I think I got from that guy, he explained the bubble will create itself when you have the right condition. You don't need to come with a bubble from outside.
No, that's right. But think about the control you would have over the bubble that's formed if you could put a micro bubble of the particular gases you wanted to implode rather than just the air that's inside the water of the sphere or the vapor, the water vapor itself. So this is the idea.
I think the water vapor will be the predominant gases in the bubbles.
That's right. That's right, the predominant gas. But what if it had, for example, this gets to my other new gadget of the week, or get full of them here. This little unit is, let me see if I can make it work here. I have to pull the lights off, I think. Not that much. Even then you probably can't see. Oh yeah, there we go. See how this glows in the dark?
Yes, what
Oh, this isn't something that you charge up with the light and it glows in the dark. This glows in the dark for 10 to 20 years like this.
okay, so it's like in the old watches that was self-luminant.
Well, they were radium, but this is it broke. This is tritium, folks. This is real tritium hydrogen 3 gas. And that's what allows it to glow in the dark for the next 10 years continuously.
Okay.
Okay, so that's interesting, I thought. You know, you can get these now. They're a key ring. You can get them for about 20 bucks or so. I decided I wanted to have some tritium in my life before I die, or maybe I'll die from it. Apparently it's not hazardous. You know, you can handle it, whatever, put it in your pocket. That's where your keys are. And it's not a hazard. It's not even a problem if the thing was to break and the gases got out. It's such a minute amount of tritium that it would be, you know, dispersed in the atmosphere and so on. You wouldn't want to break a whole bunch of them in a room that was enclosed and, you know, breathe in the fumes or inject it into you or something. But generally it's actually pretty harmless. It only takes a small amount of plastic, thin layer of plastic to actually stop the radiation and so on. But it's really a cool idea. Mr. Keshe has talked about tritium and of course deuterium as well and so on. And I'm thinking, well, what if you could take a little bit of tritium? I have my thing here. Suck some out, pop some in there. Hey, instant reactor. Now, when you think about it, the actual reaction that occurs in a sonoluminescent bubble is, they say, can reach up into the millions of degrees Celsius.
Yes.
Or Fahrenheit, doesn't really matter at that rate. And it can cause fusion reactions can take place
Yes.
in that environment. And that's what I'm interested in. I want to create a plasma, a free plasma in the center of this using the sonoluminescence or some derivative thereof. It doesn't have to be necessarily sonoluminescence the way it's been done in the labs. I think there are other ways to do it that haven't even been discovered or investigated properly yet. So in that realm, that would be really nice to be able to create a sonoluminescent bubble in here that by itself gives off light. Of course, it's not efficient. I could put 100 watts into this and only get maybe 1 watt of light out of that tiny little glow in the very center there. But on the other hand, what if there were other gases involved during that fusion process, and maybe we could create other materials, for example, or create more energy by using other combinations and really getting the action going on that implosion bubble situation. So in that sense, I actually made a little drawing of it. I don't know if you can see it. Yeah. So when you think about it, I didn't want to get into all this right now, but I will. If we had that voidness bubble in the middle, for example, that's created through sonoluminescence, it's basically an expansion voidness, and then that bubble collapses. And when that bubble collapses, the rate of acceleration of all this water or physicality stuff it accelerates at up to, they measured up to Mach 4, and it actually goes to infinity if you do the calculations. But they measured Mach 4 speeds of this water rushing in all to that center point all at once, and that creates a shock wave that it creates these enormous temperatures and so on. The temperature rises as compression takes place, and this can happen in a few picoseconds, that it gives off a bunch of light and then it's gone again, and then it starts the cycle again, and a few picoseconds later it builds up, gives off another shot of light, and it does that billions of times per second, so we perceive it as being a consistent little glowing light. But it's actually just picoseconds at a time shooting off these pulses, and it is a pulse. It's a definite vibrating pulse frequency, and your ultrasonic device this transducer that we have here, trying to make this bubble contract and expand, it can be quite a few hertz off, and this bubble will find its own natural frequency and still be able to continue with doing its thing, even though it's not stimulated at directly the correct frequency for itself. So what I wanted to point out here is something important, which is we got this idea of the bubble expanding and contracting, and normally it's water vapor, H2O, in there, gases and so on. But if you look at this voidness of the bubble, let's say it's just voidness and there's water all around. This is all water around it.
Yeah.
How many molecules are going to be on this interface? Number one, I want to calculate this week. And say that's a bubble, maybe a 1 millimeter bubble, tiny little bubble. That's what they'll be, is less than a millimeter. Pardon me?
That would be a lot.
Yeah, that's probably you mean 1 millimeter is a lot, or the number of molecules?
I mean the number molecules.
Yeah, it'll be a huge number on the inside. I'm talking about just on the first layer inside there, and it'll be some huge number. Okay, well, how many of those out of that huge number are, number one, how many are deuterium? And you can calculate how many. All water has a certain percent of deuterium. I think it's 1 in a million, and or somewhere around that range. It might be quite a bit less actually for deuterium. And then how many are tritium? And you can again calculate all water has a certain amount of tritium atoms in it, so therefore that's a certain number. So we have in this active surface here a certain number of deuterium atoms, a certain number of tritium atoms that we can actually calculate. And furthermore, this is the really fun part. Water, it turns out, is self-ionizing. That means every so often, turns out about every 20 hours, water, a molecule, that H2O, it's got its certain, it's got the O and the H and the H. Should have a better pen here. The O and the H, and that's, I think it's 109 degree or 109.5 or something like that. Angle between the two hydrogens and with the oxygen and so on. Okay, but every 20 hours, this molecule suddenly goes and splits off a hydrogen, it takes this OH and basically separates. You get atomic ionized hydrogen coming off this molecule, but within a few picoseconds later, this hydrogen snaps right back on and becomes water. It becomes it joins with the H and O again, become the water molecule again. So this is known as being the fastest chemical reaction that they've ever measured, apparently. So it's interesting that every 20 hours this self-ionization takes place. We get to have an ionized hydrogen just by waiting. But see, every moment there's enough molecules here that there'll be billions and billions of these self-ionizations occurring inside this sphere. So we have some interesting conditions happening inside this imploding, exploding, expanding, contracting bubble situation. And I think that we have a possibility of, especially if we're, see, the whole thing that I hope to do different is this whole thing is rotating. The whole sphere, there'll be a line of rotation here inside this sphere when it's sideways in the lathe and whatnot, or other ways of rotating, high speeds with smaller bubbles. And rotation of this bubble stabilizes it and makes it so you can work with it a lot easier than trying to create it in a sonoluminescent situation where you have to work against gravity all the time that shoots the bubble up, and you have to try to keep that bubble trapped down, and it shoots off and does stuff and so on.
That's why I disagreed with you about putting in something at the center, because you're fighting gravity. But what I think you should do is to make a condition that the only place this little bubble can exist is right at the focus point of the parabola.
That's exactly, well, of what parabola? There's no parabola inside the rotating sphere.
Let me show
what we end up getting is a pencil or a tube going through instead of a parabola. But the bubble can be controlled then. With rotation, you see, all the bubbles, you saw in my lathe there earlier, all the bubbles go toward the center when there's a rotation of the sphere. Let me show you again here, maybe you can see it. So that's the whole thing about the rotation that gives control. And that's the interesting part that I find.
But you can have the control with pure geometry. You don't need to spin anything.
Well, how are you going to keep the bubble in the middle without some sort of mechanism to keep it in the middle? It always wants to go to the top because of gravity, buoyancy.
Yeah, but you know the bubble exists only for a very short time, then it collapses again. And
it's still affected very much by the buoyancy, and it's very hard to keep the bubble centered because it always wants to go up.
Yeah, but then you are talking about a big bubble. I'm talking about the very small bubbles that is created.
Yeah, it still warps the whole shape of the bubble and the whole works. This isn't going to work right because of this thing attached on here, but let me just whip up some bubbles, and you can see here, like this is the bubbles here happening. It's going to be a lot of vibration with this setup. Oh well. And as I increase the speed, parts flying off here. There's the tube that forms, right? Yeah. When there's a laminar flow at a certain speed, it all becomes a tube in the middle. Well, if you get rid of all that air, then all you get is a few tiny little bubbles instead of that tube. All the bubbles in the entire thing are just in the center. And then you can remove bubbles as you wish with the I can remove bubbles with my setup here with the syringe, you see. I can put it in through there and remove all the tiny little bubbles except for maybe one that I want to leave inside. And that way it's always centered. Well, I control it's always centered along this center line. The bubble could be down here, it could be over here, it'll move back and forth. And I can control that by raising and lowering one end of the lathe, basically. It moves the bubble along, and I can actually center that tiny little bubble right in the very center of this while it's rotating and get everything adjusted just right. So that way it's already centered, ready to fire essentially, and it may be through some other mechanism other than sonoluminescence. maybe just a vibration, or maybe through the interaction of ganses and plasmas and whatnot inside.
And what you actually are trying to make is a reactor core, just a very
Yes.
tiny one.
Yes, exactly. Yes, that's it. That's exactly what I wish to create, is a reactor core in the center of this rotating core.
Because what you have is compression and expansion, right? You create the bubble, and that's just the pre-states, the precondition. And then when it collapses, you have the compression of the field, and when you get this compression, you will. I think in order to have these energy gains they have reported doing this, it must be so that when the bubble collapses, you concentrate the field and then it expands. You don't see it because now it's flat. Right?
Pardon me, you don't see it because, say again?
Yes, I say when you have the bubble, you create the bubble and it becomes of a certain size, and then the energy disappears and it collapses again, because you have made a kind of vacuum situation inside the bubble, and that together with the surface tension of the water, that is very, very strong force in this size, and the vacuum, then it accelerates and collapses.
Right, yeah, at Mach 4 speeds.
And when it does that, then it creates a plasma field that expands. And that you cannot see, you can feel or measure in some kind, but I think when the sonoluminescence creates you have some friction that generates the light, as I see it. But it's actually it's a plasma field that expands from the collapsing bubble.
Yeah, exactly. So it gives us the opportunity of a real plasma to experiment with, essentially, and without having to use high energy, like high voltage, or although I think using voltage, maybe even a low voltage, would be enough to initiate a sonoluminescent bubble as well. Different mechanism, like a spark gap, essentially. Using the bubble as a spark gap is another experiment I want to do.
But you know, I worked with ultrasound for 8 years.
Okay, and, that's why you're up on that, yeah.
Yeah, and what I learned is you cannot have air in the equation.
Well, that's right. The water actually in sonoluminescence needs to be degassed first, they call it, which is removing the air from it, either by boiling it for 10 or 15 minutes, or easier way, a better way, is to use a vacuum pump and essentially boil the water for a while to remove the excess air from it.
What I know is that if you have air in between the transducer and the place you want to have energy, then the air dissipates it all. You need
what they've discovered in a science paper I read is when the sonoluminescent cycle starts, and it is a cycle, the first 100 or so implosion and expansion contraction cycles basically eats up the oxygen in there, and oxygen and nitrogen. They get dissipated from the bubble by some kind of chemical reaction that takes place, high temperature or whatever, some kind of scavenging type reaction takes place. And after about 100 hits of this, the air is gone out of the bubble, leaving just the water vapor as the possibility, and that way there's a lot less interference with other gases to create the plasma. A plasma is relatively easy to create with argon, for example. So what do you have left when you take out oxygen and nitrogen out of air? You have
You
argon.
have 1% argon.
Well, you'd have 100% argon because the
Yeah, because
oxygen
the other
and
things are
the,
gone.
yeah, right, and all that's left is the argon in a way. So that's interesting, and that to me means, well, it's easy to create a plasma with argon. That's what they use for room temperature and room pressure plasmas now in hospitals for decontamination, that sort of thing. You use an argon
Yeah.
gas with a spark gap essentially, or a dielectric gap, and it creates a plasma that you can put on your skin, and it creates amazing healing rejuvenation effects for people with burned skin and whatnot. So yeah, that's interesting stuff to think about there.
What I maybe I should just share a very simple drawing I made for you.
Okay, can you do a screen share?
Yeah, no, but I can just turn on my camera, can't I?
Sure, yeah.
You see it?
No, just see a darkness on your. Oh, now it's coming through. Just a second here while I get it lined up on my screen. There we go.
Yeah.
Okay, yeah.
I have to. Yeah, now I can see. It's good you have the big, so I see myself here. See, if
Yeah.
you have some kind of enclosure, you have a
Yeah.
kind of enclosure here, and the thick line here on top is the ultrasound transducer, piezoelectric, and that you can control with voltages about 1 to 200 volts, and that's quite easy to do because of the transistors you can get nowadays. And there you have the parabola, and then you send these waves down here, and they focus in a single point.
Right. Well, the idea of having a sphere as a resonator is like having a parabola all the way around, essentially. As the sphere vibrates, it focuses on the very center. And so you can actually have the transducer on the outside of the sphere as well, if you're rotating the whole sphere as a structure itself. So I guess there's a couple of different methods that way.
Yeah.
Usually
But
they have to glue the transducer right on the sphere, otherwise it won't transfer the energy properly. But putting it inside, I think, is a better idea. If we can have a waterproof and variable transducer, that would be ideal.
You know, when you get this is just a ceramic plate when you look at it.
Yes,
and then
right.
Metallized. You know, it's very basic. It's just like when you have this little, what we call it in English, you know, a gas lighter.
Yes,
when you
right.
press the button,
The
you hit some
piezoelectric thing, yeah.
Yeah, piezoelectric material, and it's exactly the same in the transducer. You have when you have a piezoelectric material and you press it, you generate voltage, and if you put voltage on it, it deforms.
Right, yeah, good point. So,
and that guy that told me about this said that if you do this right, you get the right mechanical design of it, then you will have the possibility to focus all the energy from the transducer in a single point.
Yeah.
And this way you reach the energy level to create the bubbles.
Yeah.
And you don't
more
need to
efficient. It's more
What?
efficient that way, because that's this process is notorious to be pretty inefficient if you just have a random sort of wave happening there. It needs to be focused,
Yeah, and I don't know, maybe you run 10 or 50 watts on the transducer, and then you also have the advantage that it is in the water, so it gets cooled.
Yes.
And you have a very, very high power density in this point.
Right. So
this is in the other way here. It's round. It's not a line. It's a round thing like the headlight in the car.
right, yeah, interesting.
And you have no
So if
problem.
you, for example, had some GANS material right at that center point where everything's focused, or you had, say, a GANS water of some particular
Yeah.
type that was in there, the fusion process may create new materials through that sonoluminescent process. That's what I expect. We can then see. That's why I like the idea of using a hypodermic syringe and injecting a certain gas in there. We cause the sonoluminescence, and it can, with the temperatures and the pressures involved, could create new materials. Perhaps, maybe taking turning lead into gold, something like that. Who knows? It's very possible. That's what, when you have those free hydrogens available in that center, you basically start using them as building blocks and you start creating whatever you wish with hydrogen. It is the basic building block of the universe. So I think it's quite exciting in a way to conceive of this as it's sort of a micro laboratory, you could say. And these bubbles are not big. They're you can barely even see the bubbles. They're so small.
Yeah, that was my point, that you don't need to rotate this, and you don't have to fight with gravity because the lifetime of the bubble is very short. So it doesn't have time to rise.
Yeah, my dream is to actually start with a tiny little bubble and go for something a little bigger and more extravagant from that. So,
but you cannot do that. I don't think it's possible because of the speed it happens with.
Well,
you create a bubble and it collapses, and if you have a long distance, you don't get the acceleration. And I cannot imagine right now how you could make a big bubble, but I can imagine the small bubbles.
yes, right. I know what you mean, but imagine a bigger bubble and having the bigger bubble implode into the same tiny wee bubble that the little bubble goes. You'd have even a higher acceleration rate or a higher speed of implosion, and a much greater effect out of it if it was possible as well. So that's kind of the holy grail of implosion bubbles.
Yeah, but you will get much more than one bubble here.
Yes,
you will
right.
get a lot of small bubbles, first thing. And the second thing, by varying the material you put in here and by varying the pressure.
Yes, exactly. That's exactly right.
Because
What if you had an enclosure around this water that was pressurized to 150 psi, for example, pushing in on that water all that time?
That's why I've drawn this one. It's a pressure chamber.
Yeah.
I think that
that's
could
the way to go.
That could be a reactor core also.
Yep, absolutely. I believe it.
Because I think every of these small bubbles do the same as, I'm new. I haven't seen all the videos, but I'm slowly catching the idea of what you try to do with a reactor cores. And I think,
like for example, you talked about piezoelectric. Well, it turns out that zinc nanorods are piezoelectric. When they're bent, they give off electricity, and so they must be contrarily when you put power into them, they probably bend and create a sound, or at least a frequency or a wavelength. So it's entirely possible that the zinc that we've been using could very well form a perfect resonator, or could be used perhaps. Maybe we can combine it with our plasma batteries and plasma capacitors to form kind of a cyclic sonoluminescent hybrid of some sort. It'd be interesting to combine the technologies, I think.
Yeah, because when you look at, I have been interested in this field for 8-9 years, and what we have seen often is that you get some effects if you bias something and then some frequency to a bias. That's a
So it's
basic principle.
sort of like
If you
in
call it friction,
sort of like
you
in the older tubes. This is like tube technology that we're working on, but it's taken to another level, you could say. They had biases with tubes, and you'd have a sort of a coil, or not a coil, but a grid around an initial an initiator, maybe a high voltage coil or something that glows in the middle, and you put a grid around that, and you charge these different grids with different charges.
see if you have some kind of process, and the process it operates at the level here at the little wave, and you have a transducer, it is able to generate the power level of the ripple, but it's not able to reach the absolute level. Then if you can make something that makes a bias, so you raise to that level and then you vary with some frequency around that level, then you get a process.
Right.
That is why I draw this, because if you need some certain pressures, higher or lower, maybe you could also benefit from lowering the pressure, as
Well,
long
that's
as you
it. If you can create the gradient, between them, especially if you can create pressure at a certain point and reverse pressure or vacuum at a certain point, and get the excesses of both involved in that reaction. Like, what about using a denser material, or maybe a lighter material would work better, like alcohol or oil, in that sense. Maybe that would work better than water for creating the bubbles and whatnot. There's still a lot to be looked at that way, I think.
I think there's no doubt that if you have a liquid and you have some pressure waves, then this phenomenon will come. But the result you get from doing that exercise is probably material dependent and pressure dependent. And I think if you have ganses there, what happens then?
Yeah, right. Yes, exactly.
Because you can create some very large energy levels there.
Yeah, and that might be where the ganses excel. Maybe that's where they're designed to work, is in those kind of energy levels. They might not shine until, literally, until those energy levels.
And now I will say a theory I have. I don't know if it has any reality, but I will tell it anyway. There was an American guy, he experimented with spheres and light fluorescent tubes. Isn't it CFL? It's called, the lighting system with a long glass tube with a mercury vapor in it.
Fluorescent tubes is what we call them.
Yeah.
CFL's the little wrapped up ones in a spiral. Yeah.
If you have a long tube, I will make a little drawing more, because I think this is central to some of the effects we want to have. See, I have tried this, and I have obtained some very, very steep gradients. 8 kilovolts per microsecond I have achieved with this setup. What you have here is a CFL tube, and there are these glowing incandescent in the end to heat up the gas. But for this experiment, experiment, that is not used. You just use the heating wire as an electrode. Then you have some copper foil around. You have copper foil around the tube, and it's separated by a gap because it creates very, very large voltage. So if you now look at this, you have not energized the electrodes in the end. And now you look at the two foils. You know, if you have a capacitor, the capacitance is a function of distance and area of the plates. And if you look at a foil and you look at the area you have around the tube, then the area is very, very small, and you have quite a distance in order not to get sparking between the two foils. So you have a very, very low capacitance. See, if you now charge, you have some voltage source and you charge these foils to a high voltage. No, the other way around. You have energized the tubes and you get a plasma in here. The plasma is conducting. So it actually is kind of putting, if you just had a glass tube and you put a metal rod inside it, now you have a capacitor here. You have actually two capacitors in series. If you have from one wire here, you have this capacitor, then you have a capacitor where you use the glass tube as a dielectricum. Then you have a conductor to the other plate, and there you have a dielectricum again. So this is effectively two capacitors in series, okay?
Yeah, I was thinking of something similar, but with this. So you could actually create your coil here and a coil on the other side, and because, like you're saying, it's a conductor in the center, and you could actually have taps off of this for various appliances, various devices could have different voltages and so on. You take off your center core. I think that's similar to what you're speaking of.
But see, this is very fast acting, because now you take a voltage source and you charge these two capacitors in series. They will take half the voltage each on the dielectricum, right? And you charge it maybe to 1000 volt or something like that. Now you remove you stop energizing the plasma, then it disappears. What happens to the voltage when you do that?
Well, it probably peaks and probably has a impulse or a spike.
Yeah, if we make this capacitor so that they have a ratio of 1000 in the capacitance in the two situations where it's energized and it's not energized. If you have a ratio of 1000, then when you de-energize, you will get 1000 times more voltage on the capacitor. Then you will get 1,000,000 volts, right? If you have,
in theory, yeah, okay.
Yeah, it's not only theory; it works so.
But what is the net energy output or power output, not just the voltage? Because the voltage is, depends on the amperage as far as what you get out for usable power.
When you do this in a resonant circuit, you get an energy gain here. This can be free energy, but it has a problem that it's very noisy.
Okay. Well, that's one we'll have to keep thinking about. I'm going to have to...
Yeah, but now,
go ahead.
I just told you this in order to get to the next step.
Okay.
Actually, guys, I got something. for borrow you, I get something was actually very close what you're talking about. This is the way how I build capacitors or batteries. Depends what you need it. And because normally everyone use normal wire like a core, just one single wire or just few wires spanned together. So I go for a completely different direction, and that's what I do. Okay, perfectly, because I got already done. Wait a moment.
Couldn't we do this, that I just finish this little explanation and then you can continue with something? I would just make the point here about the bubbles. Okay?
Okay, yeah, go ahead.
See, the reason the voltage gets so high here, of course, you have to make the circuit so you don't have any places where it ionizes, because then the energy gets lost. And but the principle here is that you have a charge and you reduce the capacitance, and then the voltage rises. There's an equation for that, and it works in practice also. So now you have created your bubble here. This is the bubble you create, and then the bubble collapses. What happens with the charge here? Because when you have a sphere, it has a charge. It will have a charge. When this collapses, what happens to the voltage gradient in the surface? The capacitance gets lowered, just like I showed up here. The capacitance is dependent on the radius of the bubble. So when the bubble gets very small, the capacitance gets very small. But the charge cannot just disappear in the water, because the water is not conductive when it's pure. So you get a very, very large gradient here. I think this principle lies behind Schauberger's UFO, where he did some mechanical stuff with water. I think that's a principle, because here you also create plasma. You must do it because it's a very, very powerful thing you do when this bubble gets very small.
Definitely.
I just speaking basic physical properties about what we do here.
Yeah, it's a good point. Definitely a good point.
Okay, that was just what I would come with as an input for you.
Thank you, Eric. Thank you. Go
you.
ahead. Yeah, Tom.
It's gonna be shortly. Just shortly, because I know they.
Yeah, I gotta wrap things up here soon. I'm fading.
Okay, the concept, because I mean we're probably sitting on same idea. Okay, but everyone look at it from different aspects. So that's my core to the capacitors. Capacitors looks like let's say that's the capacitor. Okay, according to your drawing, that's your tube inside. Yeah.
I cannot see anything.
Okay.
You might have to readjust your set there. You should be able to see them there now.
Right.
Just select a different setting. I think switch to a different view or something. Can you do that, Eric?
What should I do? Under the video setting.
Yeah. Should be able to select. Maybe it's what, speaker view, or switch to active speaker, or somehow. What are you seeing now?
I just have a black screen with Thomas' name in the bottom.
Oh.
Maybe I can go up to the top and find Thomas there, and then say pin video. Is that the method?
You could try that. I thought it should come through automatically since I put it on Spotlight.
Okay.
See if I cancel.
There.
Okay.
All right.
All right, go ahead.
Okay. Sorry for cables. Okay, this is the pretty much. I mean, it's not the same, but I think we're talking about very similar things. And this is my core. This is my capacitor. This is the 4 capacitors all together. 3 layers.
Is that plasma capacitors?
Yeah, absolutely. Yeah. The titanium inside. Titanium. Oh, sorry, because this is I didn't get enough light. This is the titan, and the copper inside is like a two things inside. Outside is titan. Okay, but that's the capacitors part. Okay, and that's the most important because that's my core, that's my rod. And as you see, this is the rod is actually tunnel. It's a tunnel. It's completely empty inside. The tunnel starts here and finish here. And this is my symbolic tunnel, yeah. And I don't get only one size of wire. This is like the main wire is 1.6, classical one. We'll use very often to Magrav and stuff like that. So the next one, top of this one, this is the next wiring. This is the 1 millimeter. The next between the 1 millimeter, because the 1 millimeter is smaller and they create basically gaps, I just go with the third layer. The third layer is 0.6 millimeters. So we got 1, 2, 3, one top of another, something like that. So this is like I'm going all how the rod is long, the extra capacitor top of the rod. So, but it's not the 1-3 because the capacitor in the rod is close. So the first wire finish here, the second wire finish here, and the third wire finish here. That means this both the smaller ones, as you see, they just close inside. So I get something like a reactor inside. So this is my tube. It's 1, 2, it's wiring around, and here I got something like a spark gap. So, and top of this one, I got capacitors. It's gonna be very symbolic, Keshe. All right.
So you are saying that while you have a spark in there, you have the plasma.
Yes, exactly, and they connected. That's as on your drawing, but everything happen in open condition. Okay, if the next step is just close this capacitor, basically, or battery, whatever you're gonna do it, and in some container, gonna be plastic nano container with some, for example, CH3 or whatever, your combination of gases, and this is the. I think they're gonna be. I don't like touch them. Okay, you probably see all this. Okay, 3 different wires, and it's completely hollow inside. The same idea, like in this lamp, as you mentioned.
But you need to have the tube must be dielectric in order to get the effect.
Yeah, but this is the plasma. This is the. I don't look in the dielectric things now because I just create a field.
In effect, it is dielectric because of the nano-coating.
Exactly. I mean, if I'm gonna put some voltmeter here, you're gonna spot this rod generate already electric energy. So it's in nano-coated. So anyway, I got a reactor inside, same way like you mentioned on your sketches. So and the top of this one next tube, in the same idea, but with the one different. I didn't close inside. This part is open because is I don't like disturb this, but it's gonna be like that. Tube inside the tube, and inside the capacitor or battery, whatever, I got always hollow tube, and this hollow tube gets actually unlimited capacity for plasma or whatever. And now only I just need to figure out with the right connection with the gases, with this element, and I just still do some experiments, as you see. This is the ongoing experiment.
It'd be nice to see the whole thing inside of a vacuumed out tube of some sort, like an actual vacuum tube.
You know what I think?
It might start creating a plasma on its own with just in a vacuum.
You know what I think? That's probably gonna happen soon, because I got big balls, polymer balls like that, but the bigger ones, the really big ones. And I like to put the capacitors, the balls like that, and fitted with the gases. I'm nano-coated and some CH3. And actually, basically, the idea is create condition for all the situation. I mean, because the one thing, this is my spark up here. And the next things, I need to actually create another condition and extract the fields, because it's not only one, it's many fields. So that's the way how I looking for solution. I think we're pretty much on the same, but everyone look for different angle. That's only one difference.
Thank you for showing that. It's good.
Sorry for bothering.
But I can just mention that I think it was Higgins, the name of the guy that did this with a cube. He placed these fluorescent tubes into a sphere, and he was able to create lift just by Coulomb forces. But he was also able to destroy all the TV sets in the whole neighborhood.
All right, my neighbors, sorry.
Yeah, it's all for science. Sorry about that. Your new plasma TV is junk.
And he told the electric company that there was a squirrel that was or the transformer going up at the pole.
Yeah, a bit of a weasel more than a squirrel, perhaps. Yeah.
Okay, gonna be a few days from London without no electricity extra. That's what the city needed. All right, thank you.
Yeah, thank you.
All right, well, I'm gonna have to shut things down here. It's just been too much fun, so it might have been 5.5 hours. Does anybody else have something they want to show? No, just kidding. Actually, does anyone else have something that they want to say or show at this point as a ending thing? As I don't like to have any questions out there that people might have or comments they'd like to get out before the ending. So now's the time.
I would like to say thank you, Sir Rick.
Absolutely fantastic, Rick.
Thank you. That was good. Thank you for the input there, and thanks for the input from everybody. That was really good dialogue there, Eric. I appreciate that you're putting your one of your specialties to use here in a way, and I appreciate that input on a level about the sonoluminescence and so on. There, it's great stuff. Yep.
Yeah, it has been demonstrated working. So I guess it's just a matter of designing it right and putting it together. Then you get the effect.
Yeah, that's right. And because we have in a way, a greater understanding with the plasma technology and organzas and nanotechnology, I think there's ways we can put it together that the scientists that have been doing the sonoluminescence, which has only been in probably the last 10 years or so that it's even been looked at, and most of that in the last 5, and to come up with something a little different but still effective and generating more energy out than what's put in. That will be the key, or at least being able to transform and create perhaps new materials or other effects. Light would be good, heat would be good, some sort of useful effect out of this phenomena. So stay tuned, we'll keep working on it and try to get things, stop spraying me and stop vibrating too much and all this kind of craziness. And maybe someone else out there will come up with some way of doing it.
I can add that these you can get these ultrasound cleaners for cleaning knives and stuff in hospitals. They are not that expensive, and there you get the drive electronics. Then we maybe have to modify the frequency a bit, because I guess they are made a bit off tune not to get the effects while you clean your knives and scissors and so.
Yep.
There you can get quite powerful stuff.
Yeah, I've been looking at that. I wonder, like they're made to create a vapor, for example, a mist. You can have a, little waterfall set up in your home and create a mist around the waterfall with these ultrasonic vaporizers. What would happen if it's inside of a closed container, like this? Where does the mist go? And if you had this rotating, your mist would then be in the center line of the rotation again. So. And that gives you a chance to make little pockets of mist, and actually you can create bubbles of mist perhaps that could be then used with the ultrasonic to create the sonoluminescent effect. There's so much to think about, but we have to end it for today.
Yeah.
I remind people. We can't go off on too many other tangents here, but if there's anything else anybody wants to say about today's activities, then that would be good. Otherwise, I think it's time to shut down. Okay, let's end it for today and carry your thoughts into next week, and we'll carry on with our shenanigans here and trying to enlighten a few topics as we go along. So, once again, thank you everybody for attending for Keshe Plasma Reactor Group for what's now is Wednesday, January 25th, 2017. And yeah, I think that'll be it for today. Thanks for the questions. Okay, I'm going to end the live stream.